Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the reading of the course manual for the fire door assembly inspector class, which will be used for my, which I'm doing for my use to be able to listen to it, to reinforce the reading of the book, to be able to listen to it audibly. The cover page is titled Guide to Annual Inspection of Swinging Fire Doors. DHI developed this step-by-step guide to give inspectors, AHJs, fire marshals, and code enforcement officers detailed instructions for determining if fire doors comply with 2007 Nfpa 80 requirements. Complex equipment and added security features make this task more complex than ever before. Read this publication before attending DAI600 course to understand how these critically important inspections should be performed and how to verify assemblies effectively and efficiently. It is necessary for you to bring this guide with you to class, as a copy will not be provided to you at the session. Your end of class credential exam includes material that comes directly from this publication. So let's say that again. Your end of class credential exam includes material that comes directly from this publication. It is important that you familiarize yourself with this material so that you are prepared. Indeed, that's the point of reading this book. And let's get started with it now. I may or may not scan this and associate it with this file so that I can read the pages along with listening to it, is what I'm trying to say. A reinforcement of both reading and listening is the concept. Published 2004. And this, I should say, is for my internal use. Table of contents. Section 1, Introduction. Section 2, General Information. Section 3, Inspection Cycles. Section 4, Safety Inspections of Fire Door Assemblies. Section 5, Inspection Reports and Record Keeping. Section 6, Nfpa 101, Life Safety Code, Inspection of Door Openings. Section 7, Inspector Qualifications, Responsibilities and Training. Section 8, Performing Safety Inspections. Section 9, Sample Forms. Section 10, Other Types of Fire Door Assemblies. Section 11, New Construction. Section 12, Summary. Section 13, Glossary. Section 14, About the Door Security and Safety Foundation. So we're going to start with the foreword. Providing life safety and security for occupants in today's buildings is an overreaching, overreaching. Let's start over. Providing life safety and security for occupants in today's buildings is an overarching purpose that drives the development of our ever-evolving building, fire and safety codes and standards, life safety codes and standards. The National Fire Protection Agency's NFPA publication, Nfpa 80, Standard for Fire Doors and Other Opening Protectives, is among the most important standards referenced by all of the model building, fire, and life safety codes. Nfpa 80 has been the de facto standard for fire doors and fire windows since the late 1950s, and likely will continue to be so for many years to come. Prior to the 2007 edition, Nfpa 80's title was the Standard for Fire Doors and Fire Windows. It established the requirements for the installation and maintenance of fire door and fire window assemblies. Additionally, Nfpa 80 required fire doors and fire windows to be maintained in operating condition throughout the life of their installations. However, the language in these earlier editions of Nfpa 80 was vague and ambiguous, which made it difficult for AHJs and building owners to understand, apply, and follow. One of the most important changes that appeared in the 2007 edition of Nfpa 80 was the requirement for formal safety inspections of fire door assemblies, which mandates that safety inspections be informed on an annual basis. Both the 2010 and 2013 editions of Nfpa 80 contain additional requirements for safety inspections of fire door and fire window assemblies. Another important code that requires safety inspections of swinging fire door assemblies is NFPA 101, the Life Safety Code. The 2009 edition of NFPA 101 was the first edition to include provisions and requirements for for door assembly inspections. Let me read that again. The 2009 edition of NFPA 101 was the first edition to include provisions and requirements for door assembly inspections for both fire-rated and non-fire-rated egress door assemblies. And, as with NFPA 80's continued development, NFPA 101's door assembly inspection requirements have continued to evolve with the 2012 edition. Inspecting, testing, and maintenance of swinging fire doors with builder's hardware require an immense level of knowledge and expertise. The information contained in this publication is intended to provide guidance to code enforcement officers and other authorities having jurisdiction, and other AHJs, building owners, and property management personnel to aid them in maintaining swinging egress and fire door assemblies in accordance with the requirements of NFPA 80 and NFPA 101. Section 1, page 1. Why life safety is important. Whether your job title is building inspector, code enforcement officer, fire marshal, or some variant of those, you represent the authority having jurisdiction, also known as the AHJ. In any jurisdiction, the AHJ's office is responsible for determining which materials, products, installations, and construction techniques are acceptable for the buildings in that area. AHJs bear the responsibility for ensuring that the buildings and structures in their jurisdiction are built and maintained in accordance with the building fire and life safety codes that have been adopted. Building owners and property managers are responsible for adequately maintaining their buildings and facilities in accordance with applicable fire, life safety, and accessibility codes on a daily basis. One of the most common requirements with which building owners and property managers need to comply is the requirement to ensure that the means of egress within their buildings and facilities are maintained and free of obstructions. Swinging fire and egress door assemblies are major components in the means of egress that need to function reliably throughout the life of their installation. Both AHJs and building owners are acutely aware of the need to protect occupants from devastating and tragic incidents such as fires and other panic-inducing emergencies that require people to hurriedly evacuate a building, space, or structure. Building elements such as an accessible means of egress and areas of refuge within buildings, spaces, and structures need to be continuously protected with fire-resistant construction, which requires ongoing maintenance and periodic inspections throughout the life of the buildings, spaces, or structures. Building, fire, and life safety codes contain stringent requirements for the construction and maintenance of these all-important elements. Perhaps the paramount concern in our society today is that for the safety of individuals, friends, family, and self. Our children's protection in school is likely the number one concern of all. Protection not just from criminal and violent acts, but also from catastrophic incidents such as fires, floods, and other natural disasters. As individuals, we are all part of the general public. In a very real sense, our personal safety depends on countless others. We might never meet those who perform the jobs and provide the services that contribute to our collective safety, but their importance to our daily lives is priceless nonetheless. The people who serve as firefighters, paramedics, doctors, nurses, and police officers are the obvious people who help to protect us. Not so obvious are the people who work in construction-related fields, many of whom have contributed their knowledge and expertise toward creating the building, fire, and life safety codes that govern the design, construction, and maintenance of the buildings we inhabit. Regrettably, significant changes in our codes most times occur after tragic incidents claim lives of people who are merely going about their normal routines. We learn from each incident and we improve our buildings to prevent their reoccurrence. New materials, products, and construction techniques are invented to enhance our safety as a result of these lessons. This guide is designed to help you understand your role in maintaining critical fire, and life safety features within the buildings you inspect, own, or are responsible for maintaining, specifically swinging fire and egress door assemblies. Fire door assemblies are installed at strategic locations within a building, forming compartments designed to contain fire and restrict the passage of deadly smoke and gases. In a perfect world, fire door assemblies contain fires and provide time for sprinkler systems to extinguish the flames. Sprinkler systems remain idle, waiting for that moment in time when they are called on to perform their function. Most times the sprinkler systems work well. However, sometimes they fail or are insufficient and cannot contain the flames or prevent the spread of smoke and gases. Their success depends heavily on the containment of flames that is provided by fire-resistant construction in ceilings, floors, partitions, walls, and, of course, the fire door assemblies, and other opening protectives that are installed within them. Unfortunately, the world is far from perfect. Door leaves are one of the few moving elements of a building that are something that we routinely touch. They are susceptible to wear and tear over time and require ongoing maintenance to keep them working properly. When door leaves are working properly, we might never be consciously aware of them. On the other hand, we become aware of them when they are difficult to open or close, and they become an obstacle we need to overcome. In addition to the fire protection properties of door assemblies, swinging door assemblies must provide occupants with access to clear, unobstructed path of egress through the building, space or structure to the public way, the street or other safe area outside the building, in panic-inducing situations. So what that means, just as an aside, you have your egress, your egress access, you have your egress itself, and then you have your egress discharge. You've got your path to the point of egress, you've got the actual egress area itself, the door, and then the discharge area. For example, let's see here now. In addition to the fire protection properties of door assemblies, swinging door assemblies must provide occupants with access to a clear, unobstructed path of egress through the building, space or structure, then to the public way, the street or other safe area outside the building, in panic-inducing situations. At the same time, the door assemblies are expected to provide a level of physical security from unauthorized entry, theft, and other acts. Occupants need to be able to evacuate a building, space, or structure safely and quickly at a moment's notice, which is why the Nfpa 101 door assembly inspection requirements are necessary. Door assemblies that are equipped with special locking arrangements, these arrangements are explained later, electrically controlled egress doors, and door leaves that are equipped with panic hardware or fire exit hardware devices are used in applications that might have serious consequences if they fail to provide a safe path of egress during emergency conditions. For example, imagine what might happen in a building where the swinging fire door assemblies in the stair towers are properly installed, inspected, and maintained in accordance with NFPA 80's requirements, but the exterior swinging door, non-fire rated doors, at the level of discharge is not properly maintained or inspected. In an emergency situation, the exterior door might not allow the occupants to leave the stair tower, causing more panic and leading to potentially fatal consequences. When NFPA 101's inspection requirements for door assemblies are implemented and enforced, they most likely will prevent the situation from occurring. Readers of this guide will begin to understand the necessity of properly maintaining fire-rated and egress door assemblies. Naturally, regular inspections need to take place to ensure that these critical elements are ready to perform their potentially life-saving task when the time comes. When preparing for these safety inspections, please keep in mind that there is an entire industry of knowledgeable and capable people who stand ready to perform these inspections. That's the point of this class. Using this guide, you will find it helpful to have a copy of the 2013 edition of NFPA 80 Standard for Fire Doors and Other Opening Protectives, and the 2012 edition of NFPA 101 Life Safety Code, close at hand, to refer to as you progress through this guide. Where appropriate, excerpted language from NFPA 80 and NFPA 101 is included for emphasis and is explained. However, these excerpts should not be construed to contain all of NFPA's requirements. This guide is designed to explain a technical subject to a non-technical audience, specifically those individuals charged with overseeing or performing routine maintenance on fire door assemblies. You can obtain a copy of NFPA 80 and NFPA 101 directly from NFPA at nfpa.org or any number of other publication resellers. It is not possible to list all of the potential door leaf, door frame, and builder's hardware applications that are used on swinging fire and egress door assemblies. Consequently, the examples cited in this guide are focused on the most commonly observed problems and situations. In many cases, it might be necessary to rely on the expertise and skills of experienced industry professionals to perform the safety inspections and the subsequent maintenance of fire door assemblies. Section 2, General Information, which is titled Function of Fire Door Assemblies. Fire door assemblies are primarily designed to provide time for occupants to safely escape a burning building or to create an area of refuge within the building where the occupants can wait safely for help to arrive. Secondarily, they are designed to protect the structural integrity of the building long enough to give firefighters time to extinguish the flames. Few people fully comprehend the tremendous forces and stresses that fire door assemblies are subjected to under fire conditions until they witness the effect fire has on those door assemblies. Perhaps the most common misconception regarding fire door assemblies is that they will maintain their appearance, albeit a bit scorched and covered with soot, and be fully functional after being exposed to a fire. Nothing could be further from the truth. During the first few minutes of fire exposure, a metal fire door leaf expands very rapidly on the fire side of the assembly. This expansion causes the door leaf to deform as it deflects, twists, and warps towards the heat of the fire. When the fire is on the pull side of the assembly, enormous stress is exerted on the hinges and the latching hardware. The door leaf must stay closed and latched. As the intensity of the fire increases, the door leaf deflects farther, exerting more stress on the hinges and latching hardware. Fluid in the hydraulic door closer will eventually reach its boiling point and begin to leak. At this stage, the door closer has performed its intended task, and the door leaf is closed. Likewise, doorknobs, levers, and fire exit hardware devices are designed to become inoperable when the temperature reaches a certain point, ensuring they do not inadvertently release the latching hardware and cause the assembly to fail. Latching hardware and hinges are designed to bear an enormous amount of stress during a fire, but they also need to be able to handle additional stresses when the superheated assembly is exposed to the water temperature and pressure from fire hoses as firefighters extinguish the flames. Cold water causes metals to contract almost as rapidly as they expanded, exerting more force and stress on the hinges and latching hardware. No matter what else happens to the assembly, the latching hardware and hinges must be operating to keep the door leaf closed and latched in place. In the aftermath of a fire, the assembly barely retains any of its original characteristics. The door leaf has become a fixed part of the assembly. Its paint or veneer in the case of wood fire doors has been consumed. Its builder's hardware has melted, warped, or otherwise been destroyed by the fire, and all that is left is a shell wrapped and misshapen, serving as a testament to its ingenuity, engineering, and manufacturing processes that produce products able to withstand fire and provide protection for human lives. Consider the consequences of failing to properly maintain fire door assemblies. A seemingly minor defect could potentially result in serious injuries and the deaths of occupants if a fire were to occur. Neglecting to take corrective actions when problems are discovered is unacceptable and is sufficient cause for the authority having jurisdiction to issue citations and fines for allowing these conditions to continue unabated. Understanding how codes and standards affect buildings is the title of the next paragraph. Building, fire, and life safety codes are documents designed to ensure that buildings are constructed and properly maintained to protect the lives and property of occupants within all types of construction, commercial, industrial, institutional, and recreational buildings and facilities. These documents are created by organizations focused on ensuring that today's buildings are built to an acceptable minimum level of standard and quality. This includes developing stringent requirements for certain elements within buildings, such as an accessible means of egress, protection from fire, smoke, and gases, and security from intrusion and violent crimes. Building, fire, and life safety codes become legally enforceable only after the jurisdiction has adopted them, many times with specific addendums relevant to the adopting region. In the United States, there are major model building codes that are in effect in regions throughout the country. They are the International Building Code, IBC, published by the International Code Council, ICC, and Nfpa 5000, Building Construction and Safety Code, BCSC, published by the National Fire Protection Association, NFPA. One of the two nationally recognized building codes, the IBC, has become the predominant building code and has been adopted in one version or another in every state. Prior, and that's the, let's see here now, that is the International Building Code, the IBC. Prior to the creation of the IBC and NFPA 5000 building codes, prior to the creation of the IBC and NFPA 5000 building codes, other building codes were used throughout the country. In the northeast region of the country, the National Building Code, NBC, published by the Building Officials and Code Administrators, BOCA, B-O-C-A, was the primary building code. In the southern region of the country, the Standard Building Code, SBC, published by the Southern Building Code Congress International, SBCCI, was the primary building code. And the building code that was primarily used in the western regions of the country was the Uniform Building Code, the UBC, published by the International Conference of Building Officials, ICBO or ICBO. In the late 1990s, BOCA, ICBO, SBCCI merged to form the ICC and ceased publication of their respective building codes in favor of creating a new model building code to be used uniformly throughout the country. The International Building Code, IBC, what we're saying there is that those three organizations merged to form the ICC, ceased publishing their respective building codes in favor of creating a new model building code to be used uniformly throughout the country, the IBC. Concurrent with the development of the IBC, NFPA developed the Building Construction and Safety Code, NFPA 5000, as an alternative code that would similarly be used throughout the country. While publication of the legacy codes, such as NBC, SBC, UBC, has ceased, they will remain in effect in certain areas until their respective jurisdictions adopt the IBC and or the International Fire Code or NFPA 5000 as their next building and fire codes. In addition to the above-mentioned building codes, which are designed to govern the construction, there are two other codes that are used to ensure that occupied structures are satisfactorily maintained. The first is published by the ICC and is titled the International Fire Code, IFC. The second is published by NFPA and is titled NFPA 1 Fire Code, a supplementary code that has limited application as a building and fire code is NFPA 101, known as the Life Safety Code, LSC. Unlike codes, standards are documents that are designed to establish an acceptable minimum level of quality to ensure that products, as in the case of fire and smoke door assemblies, meet the requirements of the applicable building, fire, or life safety codes. Standards are not viewed as legally enforceable documents until they are incorporated into a building, fire, or life safety code by reference, extraction, or excerpted language. For many years, NFPA 80, the standard that establishes requirements for fire door assemblies and their installation, has been referenced by all the previously mentioned model codes and is recognized as the de facto standard for fire door assemblies. NFPA 80 and its effects on buildings. NFPA 80, standard for fire doors and other opening protectives, contains specific requirements for the formal inspection of fire door assemblies to ensure that they are properly maintained throughout the life of their installation and will function properly under fire conditions. Under the provisions of NFPA 80, fire door assemblies are required to be inspected on an annual cycle, and written documentation of these safety inspections is required to be kept on site for review by the AHJ. Previous editions of NFPA 80, up to and including the 1999 edition, contained requirements for ongoing maintenance and care of fire door assemblies, but the language in these earlier editions did not contain specific direction as to what items were required to be inspected or the frequency of inspections, nor was there a requirement to maintain records of these inspections. Consequently, many fire door assemblies have fallen into various states of disrepair and are not able to provide their intended protection. As of the writing of this guide, there are 3 editions of NFPA 80 that require formal safety inspections of fire door assemblies, which are the 2007, 2010, and 2013 editions. The latter editions contain additional inspection requirements that do not appear in the preceding editions. Understanding which edition of NFPA 80 is applicable for a specific building, space, or structure requires knowledge of the prevailing building fire or life safety code for the building. The 2016 edition of NFPA 80 is scheduled to be published by the end of 2015, but its requirements will not be enforceable until it is referenced by a future building, fire, or life safety code. Even so, knowing that NFPA 80's requirements for safety inspections continue to evolve, it is wise to stay abreast of its changes, as they will become enforceable at some point in the future. NFPA 80, Types of Fire Door Assemblies. This is the title of the next bulleted list, page 7. NFPA 80 includes specific requirements for the following types of fire door assemblies: swinging doors with builder's hardware, swinging doors with fire door hardware, horizontally sliding fire doors, special purpose horizontally sliding accordion or folding doors, vertically sliding fire doors, rolling steel fire doors, fire shutters, service counter fire doors, hoistway doors for elevators and dumbwaiters, chute doors, access doors. It is important to understand that NFPA 80 requires all of these types of fire door assemblies to be inspected, tested, and maintained throughout the life of their inspection. As previously stated, this guide concentrates on swinging fire doors with builder's hardware. You may need to seek guidance for inspecting and maintaining other types of fire door assemblies from their respective industries. So what I take that to mean is this class is going to focus on swinging door assemblies, fire and builder's hardware equipped. Swinging doors with builder's hardware. Of the types of fire door assemblies covered in NFPA 80, swinging doors with builder's hardware, the door assemblies covered in Chapter 6 of NFPA 80, are the most common. These types of fire door assemblies are used to protect the means of egress within a building. Example, corridors, stair towers, etc., as well as to separate rooms containing hazardous materials and equipment, such as a boiler, electrical, mechanical, and storage rooms, to protect occupants and property. In addition to providing fire protection, swinging door assemblies are installed in corridors, and stair towers often provide accessibility, life safety, and security functions, which increase the complexity of these door assemblies. Typically, swinging doors with builder's hardware are comprised of components produced from more than one manufacturer. For example, the steel door frame might come from one manufacturer, and the wood fire door might come, and it will come, from another manufacturer. Additionally, many of the individual builder's hardware components, such as hinges, locks, door closers, etc., are usually produced by a variety of manufacturers. Key to understanding swinging doors with builder's hardware is knowing that all of the products used on these fire door assemblies are required to be labeled for use on fire door assemblies. Many builder's hardware products used on fire door assemblies are referred to as being listed rather than labeled. However, as in the case with fire exit hardware, some builder's hardware products are both listed and labeled for use on fire door assemblies. Unlike swinging fire doors with builder's hardware, all of the other types of fire door assemblies covered in NFPA 80 are labeled, furnished, and installed as complete units rather than as individual components. In other words, there is only one label on an entire door assembly, whereas each component that is installed on a swinging door with builder's hardware assembly is required to have its own label or to be listed for use on fire door assemblies. Due to the myriad components that are permitted to be used on swinging fire door assemblies, properly maintaining these assemblies requires special attention, especially when there are limitations and restrictions to the types of modifications that can be made to them after installation. Many swinging fire door assemblies have unintentionally been ruined by field modifications that have compromised their fire protection properties and that thereby void the labeling requirements of the openings. NFPA 80 defines these assemblies such as swinging fire doors shall be permitted to be furnished separately from labeled door assemblies and builder's hardware if the complete door assembly, including the door, the frame, and builder's hardware, comprises a labeled fire door assembly. Let's read that again. NFPA 80 defines these assemblies as such. Swinging fire door assemblies shall be permitted to be furnished separately from labeled door frames and builder's hardware if the complete fire door assembly, including the door, frame, and builder's hardware, comprises a labeled fire door assembly. NFPA 80, section 4.3.2. And paragraph 4.2.5.2 states, except where restricted by individual published listings, a fire door assembly shall be permitted to consist of the labeled, listed, or classified components of different organizations that are acceptable to the AHJ. The latter statement acknowledges that products listed and or labeled by different testing organizations and laboratories are commonly used as components on fire door assembly, except when specifically restricted by the respective testing organization. In the case of swinging doors with builder's hardware, there are 3 national testing organizations that list and or label doors, frames, and hardware products for use on door assemblies. They are Underwriters Laboratory, which is UL, Intertech, which provides testing under its Warnock-Hersey mark, WHM, and Factory Mutual, FM. The labels attached to fire door assemblies identify which organization the respective manufacturer submitted their products to for testing and labeling. Okay, building owner's responsibilities under NFPA 80. Chapter 5 of NFPA 80, titled Care and Maintenance, establishes the requirements for the safety inspections of fire door assemblies. In addition to the safety inspection requirements, Chapter 5 includes instructions and requirements for the removal, replacement, and repair of fire door assemblies. Paragraph 5.5.1 states, repairs shall be made, and defects that could interfere with operation shall be corrected without delay. The intent of this statement is to require maintenance personnel to immediately take steps to remedy broken or malfunctioning fire door assemblies when they are discovered. For example, broken, bent, or missing closer arms prevent door closers from being able to close the door leaves, rendering the assemblies useless for their intended purpose. Likewise, a broken or missing latch bolt requires immediate corrective action, since swinging fire door assemblies are required to latch positively when they close at the time of fire. Other defects and problems require corrective action. If they do not interfere with the operation of the opening, such as dented metal doors, immediate action is not required. In some cases, lead times for ordering and installing replacement items, such as locks, fire exit hardware, door closers, etc., might take 4 weeks or more. Failure to begin the replacement process further exacerbates the problems. In addition to being responsible for ongoing maintenance of fire door assemblies, building owners and property management personnel are responsible for making sure that formal safety inspections take place on an annual basis. Section 5.2 of NFPA 80, titled Inspection and Testing, lists requirements for periodic inspection and operational testing of fire door assemblies, as well as the documentation necessary for safety inspection records. Further explanation of this requirement is included in paragraph A.5.2 of Annex A, which states, doors, shutters, and windows are of no value unless they are properly maintained and closed or are able to close at the time of fire. A periodic inspection and maintenance program is generally the responsibility of the building owner. Section 5.2.3, acceptance testing, establishes the minimum inspection requirements for fire door assemblies. Paragraph 5.2.3.1 states, acceptance testing of fire door and window assemblies shall be performed by a qualified person with knowledge and understanding of the operating components of the type of assembly being subject to testing. Key to understanding this requirement is that the persons performing the operational testing are required to meet the standard for a qualified person as defined by NFPA 80. NFPA 80 defines a qualified person as a person who, by possession of a recognized degree, certificate, professional standing, or skill, and who, by knowledge, training, and experience, has demonstrated the ability to deal with the subject matter, the work, or the project. Each type of fire door assembly has its particular means of operation and requirements. Rolling steel fire doors, for example, require a functional test that is referred to as a drop test. During the drop test, the curtain is required to close within a certain range of speed, not less than 6 inches per second and not faster than 24 inches per second. A second drop test is required to confirm that the automatic closing device was properly reset after the first drop test. Once the operational testing is completed, rolling steel fire doors are required to properly reset to the ready position. Similarly, swinging fire doors are required to swing freely, be self-closing, automatic closing, or power operated, and be positive latched in the closed position. Let's read that again. These are the cardinal rules of fire doors. Similarly, swinging fire doors are required to swing freely, be self-closing, automatic closing, or power operated, and be positively latched in the closed position. While these requirements might seem simple and easily ascertained, it requires a trained eye to identify products that are not listed for use on fire doors and that therefore violate the labeling requirements of the door assembly. For instance, NFPA 80 requires that conventional hinges used on swinging fire doors be a steel-based material or be stainless steel. It is difficult to visually distinguish brass-plated steel hinges from solid brass hinges, since they are aesthetically identical. Solid brass hinges or plated hinges with a bronze or brass base material are not permitted on fire door assemblies due to their low melting temperatures. To further complicate matters, there are builders' hardware products that have a very specific and limited application on swinging fire doors, depending on the door leaf material or construction, and sometimes on the door frame material, or the level of fire protection rating, such as 1/3 of an hour versus 3-hour fire rating. A product might be permitted on one application and prohibited on another. Building owners and property management personnel are responsible for ensuring that the persons inspecting fire door assemblies have the requisite knowledge and training to properly perform the evaluations. Depending on the quantity and complexity of the swinging fire doors in your buildings, you might need to seek specific training for your maintenance personnel or hire third-party inspectors to perform these safety inspections. AHJ's responsibilities for inspecting fire door assemblies. It is important to note that NFPA 80 safety inspection and testing requirements are primarily addressed to building owners and property management personnel. AHJs are responsible for ensuring that building owners and property management personnel are aware of their responsibility to maintain fire door assemblies in working condition. In situations in which there is sufficient cause, an AHJ might compel them into compliance through citations, fines, or appropriately punitive measures. AHJs are responsible for ensuring that the entire structure meets the intent of the applicable codes. Rarely will an individual code enforcement officer have the depth of knowledge, expertise, or time necessary to perform detailed system inspections of building elements like fire and egress door assemblies. Instead, AHJs rely on industry professionals to perform thoroughly detailed inspections like those required for fire and egress door assemblies. Safety inspections of building systems such as sprinklers, elevators, fire building alarms, fire extinguishers, standpipes, etc., are performed and documented by professionals working in the respective industry. Records of these inspections are retained on site and are presented to the AHJ during its periodic building inspection visits. Frequently, the AHJ will take time to spot check the systems to verify that the information recorded in the documentation is accurate. When deficiencies are discovered, the AHJ can require corrections to be made within a certain number of days, issue citations for noncompliance, and assess monetary fines. The AHJ has the authority to temporarily close a building until corrective actions have been completed. In extreme instances, the AHJ can permanently close a building. We're on page 11. Section 3, Inspection Cycles, Annual Inspection Cycle. Section 5.2.4, Periodic Inspection and Testing, requires fire door assemblies to be inspected and tested, not less than annually. NFPA 80 5.2.4.1. Further, Annex A, Paragraph A 5241 states, doors subject to high volume use and abuse might warrant an increased frequency of inspection. Components including, but not limited to, hinges, catches, closers, latches, and stay rollers are especially subject to wear. The intent of the Annex comment is to alert building owners, property managers, and AHJs that high-frequency use door assemblies tend to require more ongoing maintenance and a higher level of attention than fire door assemblies that have ordinary or low-frequency usage. For example, some cross-corridor pairs of doors in hospitals are normally closed to create separation between adjacent spaces. They might be opened and closed hundreds of times a day. It is common for door assemblies such as these to develop deficiencies from the constant usage to which they are subjected. Maintenance personnel are generally aware of which door assemblies in their facilities require a higher degree of attention. In these cases, NFPA 80 safety inspections can be used to ensure that door assemblies are maintained and functioning properly. The intent of A.2.4.1 is to ensure that each fire door assembly is inspected and tested for operation on at least an annual basis. In other words, the functional test verifies that each fire door will move to the closed position and remain closed, meaning latched, as it is required to under fire conditions. Annual inspection of fire door assemblies in the majority of small buildings is relatively straightforward and is not inordinately time-consuming. However, inspecting and testing fire door assemblies in large buildings and facilities could become a seemingly never-ending process. Accordingly, NFPA 80 has established an alternative inspection cycle program for these situations, the performance-based option. Understanding NFPA 80's performance-based option. Owners and property managers of large buildings and facilities that have established maintenance programs for fire door assemblies might qualify to convert to the performance-based option for the inspection and testing of fire door assemblies, provided they can document sustained levels of acceptable performance and demonstrate compliance to the AHJ. Section 5.4 of NFPA 80, titled Performance-Based Option, describes the basic requirements of the program. The following text is excerpted from NFPA 80. 5.4 Performance-based options. 5.4.1 as an alternate means of compliance with 5.2.4, subject to the AHJ, fire door assemblies shall be permitted to be inspected, tested, maintained under a written performance-based program. 5.4.2 Goals established under a performance-based program shall provide assurance that the fire door assembly will perform its intended function when exposed to fire conditions. 5.4.3 Technical justification for inspection, testing, and maintenance intervals shall be documented in writing. 5.4.4 The performance-based option shall include historical data acceptable to the AHJ. First and foremost, only the AHJ can grant approval to extend the inspection cycle beyond 1 year. Before granting approval, the AHJ needs to establish an acceptable level of compliance, such as 5% maximum failure rate or 95% acceptable performance rate, etc., which might vary depending upon the building occupancy and function. Next, the AHJ needs to review the owner's technical justification documenting the existing maintenance program, including operational testing of fire door assemblies. Finally, the AHJ might require statistical and historical documentation detailing the door assemblies. Finally, the AHJ might require statistical and historical documentation detailing the total number of fire doors inspected over a rolling period of time, e.g., example, the 5 years preceding the application for extension and or subsequent inspections, the number of documented failures within that time period, the causes or reasons for failures, and the corrective actions taken to repair them. To fully comprehend the level of documentation required by the performance-based option, read Annex J, Performance-Based Option for the Inspection, Testing, and Maintenance of Fire Door Assemblies. Technically speaking, the information contained in the Annex sections of NFPA 80 is intended to provide additional explanation and guidance rather than being formal requirements of the standard. Such information is necessary to help users of the standard understand the complexities of the performance-based option. AHJs need to be able to explain and defend their rationale for extending or reducing the inspection cycle. Their position needs to be based on technical and historical documentation provided by the owner to justify their decision. After all, the purpose for inspecting and testing fire door assemblies is to ensure that they are ready and able to provide the protection for which they are or were designed. Assurance that fire doors are performing reliably during safety inspections can Assurance that fire doors are performing reliably during safety inspections and testing should indicate that they would perform as intended under fire conditions. In cases in which the owner can satisfactorily document an acceptable and sustained level of compliance, the AHJ can be reasonably confident that the fire door assemblies will continue to be well maintained over an extended period of time. In other cases in which the documentation indicates an unacceptable level of performance, the AHJ is justified in reducing the inspection cycle to less than 1 year. In other words, the AHJ's decision to extend or reduce the time period of the inspections is based on factual data and not made arbitrarily. Performance-based inspection programs should be comprised of the following elements: an acceptable level of sustained performance, which is established by the AHJ, which can be addressed as maximum failure rate or minimum performance rate, a formally documented maintenance program for fire door assemblies, an estimate of the frequency of use for each fire door assembly, documented maintenance history, continuing monitoring of the failure rate between formal inspections, overall building condition, consequences of fire, review of failure or compliance rates, and a plan for the incremental increase or reduction of the inspection cycle. acceptable level of performance. In order to ensure that the intent of the inspection requirements is being met, the AHJ needs to establish an acceptable level of sustained performance for a particular building or facility. Paragraphs J.5 and J.6 and Annex J of Nfpa 80 present an equation for determining the maximum failure rate over an extended period of time. The equation can be illustrated as FDFR sub T equals NF divided by the product of NC multiplied by T. Right at the bottom. Now, let's define that. Here, FDFR represent fire door failure rate. Well, that's easy. Over a specific period of time, which is represented by sub T. NF represents the total number of documented failures in the same time period, which is divided by NC, the total number of inspected fire door assemblies within that period of time. In the scenario listed in J.6, the figures used result in the following equation. I'm not looking at that annex. 0.020 equals 5 divided by the product of 5 times 50. In other words, over a 5-year period, a total of 250 fire door assemblies were inspected. The same 50 fire door assemblies were inspected in each of the 5 years. Of those 250 fire door assembly inspections, 5 door assemblies were determined to be failures. Translated, the example building has a failure rate of 2% per year. Conversely, the result could be referred to as an acceptable level of performance of 98%. So, not looking at the annex, apparently the fire door failure rate so they had apparently NF, the total number of documented failures in the same period, which is divided by NC. So we've got a 5-year period. We've got 5 failures. We've got 250 openings. So what they're saying is, I'm going to imagine that there are 50 openings. Yeah, okay, 50. So they've got a 5-year period. There are 50 openings over a 5-year period. That's the 50 multiplied by 5. You're going to divide that by 5 because that's the period, that's the number of failures. That's going to give you the FDFR sub T. Okay? So 50 times 5 is 250 divided by 5, 50, has to equal the FDFR sub T, which is 0.020. Therefore, that's the 2% failure. Documented maintenance program. Owners and property management personnel need to establish a formal ongoing maintenance plan for ensuring that fire door assemblies are in satisfactory condition Let's start that over. Owners and property management personnel need to establish a formal ongoing maintenance plan for ensuring that fire door assemblies are in satisfactory condition and are fully operational. One aspect of this program should be documentation of the specific training that personnel have completed in preparation for properly maintaining fire door assemblies. Another aspect of this program should be the collection and retention of historical data, documenting the ongoing maintenance program, including deficiencies and corrections. The level of detail captured in this history needs to be sufficient to repeat the formula for determining an acceptable level of compliance over the interim period between formal inspection cycles. Frequency of door use. Door assemblies within any given structure have varying degrees of daily usage. Consider the main entrance to an office suite that has 100 employees in a high-rise building. Each business day, the main suite entrance door is opened and closed approximately 200 times when employees arrive and depart. Add to this the usage and allowance for visitors and vendors, plus comings and goings of the employees during the course of business, and the daily usage of that one opening might well be upwards of 350 cycles per business day. By extrapolation, we can estimate that this opening will cycle approximately 87,000 times in a 12-month period. Since most fire-rated door frame, and builder's hardware products are engineered to last a minimum of 1 million cycles, our example door assembly would have an approximate lifespan of 10 to 12 years, during which time, of course, it would require a certain amount of care and maintenance to keep it working properly. Other door assemblies within a structure might have a low frequency of use due to their location. For instance, a door assembly in an electrical service closet might be opened as little as twice per month and is less susceptible to the rigors of wear and tear. Similarly, swinging fire door assemblies installed across a corridor that are normally held open electrically might be cycled only during inspections of the fire alarm system and door assemblies. Door assemblies like these might never wear out and are less likely to require significant care and maintenance over time. Door assemblies that are most susceptible to frequent and rigorous usage are located in high traffic areas such as main entrances, public restrooms, and at the level of discharge from stair towers. Generally speaking, door assemblies in junior and senior high schools are subjected to significantly more abusive usage than door assemblies in office buildings. Frequency of use estimates need to be based on the nature of the building, the placement of fire door assemblies within the building, and the occupancy group within them. Building condition. When considering an extension of the inspection cycle for a building, the AHJ needs to assess the condition of the entire building. For example, fire door assemblies in buildings that were constructed in the preceding 5 years are more likely to be in good condition and operating reliably. On the other hand, fire door assemblies in buildings that were constructed 10, 15, or more years ago are more likely to be in need of repair, at least until such a time as the safety inspection records document an acceptable level of performance. Consequences of failure. Without a doubt, determining the consequences of a fire door assembly failing to perform its intended function is the most difficult dynamic that the AHJ needs to consider when applying the performance-based option. As we are keenly aware, if a tragic incident were to occur after the AHJ approved an extension of the inspection cycle, the AHJ's decision would be scrutinized. There might be legal consequences if the decision was made improperly. Fire door assemblies that are required to swing in the direction of egress typically serve an occupant load of 50 or more persons. They are also installed in rooms with hazardous equipment or materials. Failure of these fire doors could potentially result in a large number of fatalities, either by failing to block smoke, gases, and flames from spreading to other parts of the structure, or by impeding the egress of the occupants to the point of preventing them from reaching safety. The consequences of failures for fire doors that do not protect the means of egress might be less severe, at least in terms of injuries and loss of life. For example, fire door assemblies protecting a file storage room or an electrical closet within other rooms would likely not impede egress, and their failure might have less severe consequences. The other element that should be considered in this decision is the nature of the building or facility requesting the extension of the inspection cycle. Healthcare facilities, progressive care facilities for senior citizens, and our schools for children in grades K through 12 are examples of buildings where the occupants are less able to protect themselves during emergency situations, whereas occupants in office buildings, manufacturing plants, and other such buildings are typically better able to protect themselves during emergencies. AHJs, building owners, and property managers need to be aware of the possible consequences of extending the inspection program. Be aware of the consequences of extending the inspection cycle. They need to weigh the potentially fatal consequences against the time and effort it takes to annually ensure the fire door assemblies are in operating condition. Okay, now moving on to planning for extended inspection cycles. A critical element of the performance-based inspection cycle is the development of a plan for the incremental increase in the inspection cycle based on documentation accrued over time. Changes in the inspection cycle should be made incrementally while continuously monitoring the performance level of the maintenance program. Paragraph J.10 of Nfpa 80 recommends changes to the inspection cycle to be no more than 6 months at a time and to not exceed a total period of 36 months, regardless of performance. When permission is granted to increase the inspection cycle, the owner agrees to maintain the fire door assemblies at an acceptable level of sustained performance. In cases in which the AHJ determines that a building has an acceptable level of performance, the AHJ needs to reduce the time period of the inspections accordingly. Buildings with high percentages of failures might have their inspection cycle reduced to every 6 months until such a time that the owner can document that corrections have been made and can demonstrate that the maintenance program is sustaining an acceptable level of performance. It is important to understand that the AHJ will establish the increments for increasing or decreasing the inspection cycle within its jurisdiction. Changes in ownership, facilities management, building use, and occupancy might be sufficient cause for the AHJ to make reductions in the inspection cycle or revoke permission for the performance-based inspection cycle. Transitioning to the performance-based inspection cycle. Before seeking the approval of the AHJ to transition to the performance-based inspection cycle, building owners and property managers need to determine if the increased burden of record keeping and the continuous scrutiny of its maintenance program is offset by the benefit of extending the time between annual inspections. It should be understood that the AHJ's decision to permit an extension of the inspection cycle is in recognition of the building owner's or property manager's established maintenance program. The program includes periodic testing and proper maintenance of fire door assemblies, as well as keeping accurate records documenting the work performed on the door assemblies. The AHJ might require historical information spanning 5 or more years in order to fully assess the effectiveness of the owner's maintenance program and accurately gauge its level of performance before granting an extension of the inspection cycle. Paragraph 4.J of NFPA 80 lists 3 critical factors that building owners should consider before switching to the performance-based inspection program. These factors are past door reliability, resource expenditures, and administrative burden. Let's define those. Past door reliability. The first factor owners and property managers should consider in making the decision to request an extended inspection cycle is the current and historical condition of the fire door assemblies in the buildings. The AHJ is not likely to approve extending the inspection cycle for buildings with a history of poor maintenance and code violations, especially for fire door violations. In cases like this, it might take years for the owner to improve the maintenance program such that the AHJ might consider granting an extension. Resource expenditures. The next factor the owner needs to consider is the decision in the costs associated with performing the inspections on an annual basis. As prescribed in Section 5.2 of NFPA 80, against the costs of developing internal systems to provide statistical information and documentation that monitors the effectiveness of the ongoing maintenance program. Administrative burden. Number 3. Finally, building owners need to determine if the increase in the administration and monitoring of the maintenance program is an acceptable trade-off in return for the extended inspection cycle. Large facilities with hundreds or even thousands of fire door assemblies are the most likely candidates for using the performance-based inspection cycle. Let's read that again. Large facilities with hundreds or even thousands of fire door assemblies are the most likely candidates for using the performance-based inspection cycle. Typically, they have an established maintenance program staffed with personnel who are capable of successfully administering performance-based inspections. On the other hand, owners of buildings with comparatively few fire door assemblies might decide that the cost of administering and monitoring a performance-based inspection program is greater than the cost of performing inspections on an annual basis. Let's read that again. On the other hand, owner of buildings and with comparatively few fire door assemblies might decide that the cost of administering and monitoring a performance-based inspection program is greater than the cost of performing the inspections on an annual basis. It might just cost them more than it's worth. Developing a written performance-based program. Once permission for converting to a performance-based inspection safety program has been approved by the AHJ, the program itself needs to be documented in writing so that future facility and AHJ personnel understand the requirements. A copy of the approved performance-based program should be on file with the AHJ and filed with the owner's maintenance records. The written program should specify the following requirements: minimum acceptable level of compliance or maximum failure rate as determined by the AHJ. Maximum time interval between formally documented inspections. Documentation of the level of compliance. Number of failures divided by total number of fire door assemblies. Documentation proving that inspectors have sufficient knowledge to perform inspections. Maintenance history for corrective actions needed to repair failures. Level of compliance ratings for preceding inspection cycles. Section 4 now, page 17. Safety inspections of swinging fire door assemblies. New and existing installations. Generally, the requirements of product standards like NFPA 80 are not retroactively applied to products or their installations that were made in compliance with earlier editions of the same standards. However, NFPA 80 contains requirements that are applicable to existing fire door assemblies, regardless of when they were installed. Chapter 5, Care and Maintenance, specifically gives direction to the ongoing maintenance of fire doors, as well as the requirements for formally inspecting and testing them. Paragraph 5.1.1.2 states, the requirements of this chapter shall apply to new and existing installations. Performing visual inspections. Requirements for the visual inspections of swinging fire door assemblies are listed in section 5.2.3.5. Swinging doors with builder's hardware or fire door hardware, paragraph 5.2.3.5.1 states, fire door assemblies shall be visually inspected from both sides to assess the overall condition of the door assembly. Additionally, paragraph 5.2.3.1 states, before testing, a visual inspection shall be performed to identify any damaged or missing parts that can create a hazard during testing or affect operation or resetting. So you got to look at both sides of the door to assess the overall condition. You then, during your visual inspection, you're checking for any damaged or missing parts that can create a hazard during the testing or affect operation or resetting. Checklist for visual inspection of swinging fire doors. Fire door assemblies are not required to be maintained in like new condition, but they do need to be in proper operating condition in order to perform as intended. After all, a certain amount of wear and tear is to be expected over the life of the installation, provided that such wear and tear does not prevent the assemblies from containing a fire. For example, cosmetic damage such as minor scratches, scrapes, and dents that do not penetrate the face of the doors and door frames should not detrimentally affect their performance under fire conditions. The following checklist of items is found in paragraph 5235 of NFPA 80 and has been expanded upon here to better explain its requirements. A. Labels are clearly visible and legible. The labels that are applied to door leaves, door frames, and builder's hardware components need to be visible and legible. Some of the most frequently cited deficiencies on swinging fire door assemblies are labels that have been painted over, labels that have been removed, or labels that show signs of tampering. NFPA 80 paragraph 422 states, labels shall be applied in locations that are readily visible and convenient for identification by the AHJ after installation of the assembly. Physical labels on door leaves might be made of metal or mylar and are attached by rivets or adhesives in a manner that will cause the labels to be deformed or destroyed when removed. Metal door frames that may have embossed, stamped, or attached physical labels indicating a maximum level of fire protection rating for a particular application. Generally, labels are located on the hinge side of the door and in the hinge rabbet of the frame at about 60 inches above the floor. Labels are sometimes located on the top edge of the door and in the door rabbet of the head of the frame when hardware items, continuous leaf hinges, would otherwise cover them if the labels were placed in their typical locations. Labels contain valuable information concerning the construction of the door, including the name of the manufacturer, the testing laboratory, the maximum level of fire protection rating, period. Many labels have serial numbers, which can be used to assess historical information. The ability to track this information is useful following incidents in which damages have resulted due to failure of the door's performance under fire conditions. If owners have concerns regarding a labeled fire door leaf or door frame, they should contact the manufacturer or testing organization and provide them with the serial number. Painters are notorious for painting over or removing and reattaching the metal labels attached to fire doors and frames. It cannot be overstated that painting over these labels is a serious matter, as it obscures the information contained on the labels. In most cases, the information is irretrievably concealed beneath layers of paint. Labels that have been removed and replaced are easily distinguishable from labels that have not been removed. Labels that have been painted or tampered with should be brought to the attention of the AHJ to determine how the situation should be remedied. Generally, fire-rated hardware components are marked with embossed symbols from one of the nationally recognized testing labs like Underwriters Laboratories or Intertech, which serve as their labels. Some hardware products, like conventional 5-knuckle hinges, are not marked in any manner but are listed with the testing labs by their manufacturer. Temperature rise labels. Depending on the age of the building and the applicable building, fire, and life safety codes at the time the door assemblies were installed, the door leaves protecting stair towers might be required to have an increased level of protection. In addition to having a fire protection rating of 1.5 hours, these door assemblies are required to limit the transmission of heat from the fire-exposed side of the assembly during the first 30 minutes of fire exposure. These types of doors are referred to as temperature rise doors. There are 3 levels of temperature rise protection: 650 degree, 450 degree, and 250 degree Fahrenheit. The lower the temperature, the better the protection. When no degree of temperature rise is listed on the label, the door leaf permits the heat transfer to exceed 650 degrees during the first 30 minutes of a fire. The degree of temperature rise is measured from the increase above the ambient temperature at the fire door assembly. For instance, when the ambient temperature at a stair tower is 80 degrees Fahrenheit and a fire occurs in a corridor, a 250 degree temperature rise door limits the transmission of heat to 330 degrees on the stair tower for the first 30 minutes of exposure, providing time for the occupants to descend through the stair tower past the level of fire. No open holes or breaks. Fire door assemblies are intended to form an impenetrable barrier during fire conditions. Unused fastener holes resulting from the removal and/or replacement of hardware items on the door or door frame accelerate the deterioration of the door and frame materials during a fire and permit the flames, smoke, and gases to spread to the non-fire side of the assembly. Significant dense penetrations such as rust through, punctures from equipment, etc., or delamination of the door or door frame surfaces have similar detrimental consequences to the assembly's performance in a fire. Glass and glazing. Fire-rated door leaves, side lights, and transom light frames are permitted to have integral vision lights. In order for the vision lights and panels to prevent the spread of flames, smoke, and gases, the frames, light kits, and/or glazing beads around the vision panels need to be intact and securely fastened to the door or frame. Glazing panels cannot be cracked or damaged. Choices for the glass and glazing materials used to form these lights are limited to products that have passed fire testing, including hose stream tests. At one point in time, the most commonly used glazing material for fire door assemblies was 1/4 inch thick clear wire glass. Concern for reducing injuries caused by shattering glass has led to the development of glazing materials that provide physical security from accidental impacts. These glazing materials also provide fire protection or fire-resistant properties in fire door assemblies. Typically, these products do not have the familiar wire glass pattern, diamond or square. Instead, they have an etched label or listing marked on one corner of the exposed area. Inspectors need to look closely at non-wire glazing panels to verify that they are appropriately labeled for use in fire assemblies. The requirements for glass and glazing that is permitted to be used in fire door assemblies have evolved significantly over the last 15 years. And by the way, the date of publication of this book is 2014. When performing safety inspections of fire door assemblies, it is important to be aware of the glass and glazing requirements that were applicable at the time of installation. For example, 1/4 inch wire glass vision panels and lights that were installed prior to the mid-1990s were not required to be individually labeled, whereas every piece of glass or glazing material that is installed today is required to be individually labeled. In cases in which the glass or glazing materials become damaged and require replacement, the replacement glass and glazing materials must meet NFPA 80's requirements at the time of replacement, regardless of when the original materials were installed. In other words, when a piece of 1/4 inch clear wire glass has become damaged, the replacement glazing material is required to comply with today's standards, which most likely will be one of the non-wire glass glazing materials that meets today's safety standards. D. Alignment. Door leaves and door frames that are not properly aligned are not able to perform a suitable barrier during a fire. For example, the meeting stiles of a pair of door leaves installed in a frame that is not properly aligned will create the illusion of door leaves being warped. This misalignment might prevent positive latching when the door leaves are completely closed if the door frame is too far out of alignment. Misalignment might be the result of poor installation or excessive usage that cause the vertical jambs of the door frame to shift. Fire door leaves, their door frames, and builder's hardware components need to be securely fastened in place and properly aligned to withstand the extreme forces and stresses exerted on them in a fire. Missing or broken parts. As simple as it might sound, the necessary components installed on fire door assemblies need to be complete. A missing strike plate for latching hardware, for instance, prevents the door from being positively latched during a fire. Door closers, door closer arms, mounting brackets, latch bolts, and many other components have an important role in the performance of fire door assemblies. When any of these items is missing from the assembly, an entire assembly is in jeopardy of failing in a fire. Fasteners are perhaps one of the most overlooked elements of fire door assemblies. At best, missing fasteners such as hinge screws, lock face, and strike screws are indicative of poor installation and maintenance practices. Worse, missing fasteners might indicate that hardware items that were not part of the original assembly and are not listed for use on fire door assemblies were installed. Incorrect fasteners might fail when exposed to fire conditions, causing failure of the entire assembly. Inspectors need to verify that no exposed fasteners are missing and that they are fully secured in place. Inspectors might need to verify the presence of concealed fasteners in case in which hardware items, such as surface door closers, fire exit devices, etc., are obviously loose. Verification of concealed fasteners requires the partial disassembly of hardware items, such as removing cover plates, which should be performed by the owner's personnel in the presence of the inspector, especially when third-party inspectors are performing the safety inspections. Clearances. In addition to alignment, the NFPA 80 4.8.4 and 6317 also list the maximum dimensions permitted between the edges of the door and frame, as well as between the bottom of the door and the finished floor or threshold. It is possible to have doors and door frames aligned within acceptable tolerances and excessive clearance around the perimeter of the door leaves. When the top corner of the door at the lock edge has dropped significantly lower than the opposite top corner at the hinge edge, the door is referred to as sagging. Door sag can be indicative of a worn-out top hinge, which is easily corrected, or it can be indicative of a broken hinge, reinforcement plate in a hollow metal door or frame, which is a much more significant problem to correct. Closing devices. This is G. Closing devices. One of the most critical elements in a fire door assembly is the closing device. Without a properly working closing device, the fire door assembly is rendered useless. Hydraulic closers can develop leaks over time, which reduces or eliminates their ability to control the opening and closing speed of the door leaves. Technically, as long as the door closer is able to move the door leaf to the completely closed position, even if it is slamming, it does meet the intent of NFPA 80. However, over time, the stress created by repeatedly slamming the door leaves closed accelerates wear and tear on the assembly and will damage the assembly eventually. As a cautionary side note, the number one cause of personal injury lawsuits as they relate to the door industry is doors that close too fast and knock down occupants or catch hands and fingers between the door and door frame. The closing and latching speeds of door closers should be properly adjusted to overcome resistance of the latching hardware and pressure from HVAC systems without creating a hazard for building occupants. Paragraph H, coordinators. Door coordinators are used on pairs of swinging fire doors to control the closing sequence of the door leaves and to ensure that both leaves return to the completely closed position. Typically, these devices are used on fire door assemblies that are required to swing in the direction of egress when the active leaf is arranged to latch into the edge of the inactive leaf. Soffit-mounted door coordinators require the use of auxiliary mounting brackets to accommodate other soffit-mounted hardware items, such as parallel arm door closers and strikes for surface-mounted vertical rod fire exit devices. Latching hardware. Latching hardware is equally as critical as the closing device on fire door assemblies. The door leaves are required to positively latch under fire conditions and to remain latched for the duration of their fire protection rating. Depending on the type of locking or latching hardware, whether it be board or mortise locks or flush bolts, fire exit hardware devices, etc., and the configuration of the door leaves, the latch bolts have specific requirements that they are required to meet in order to be used on fire door assemblies. For example, single door leaf openings generally require latches to have a projection of 1/2 inch to ensure that they positively engage the strike plates around the door frames. However, the projection of the same latching hardware device used on a pair of door leaves might be required to be 5/8 or 3/4 inch, depending on the information on the label of the fire-rated door leaf. To further complicate this matter, there are non-listed latches and locks that might appear to be suitable for use on fire door assemblies, but that technically violate the labeling requirements since they have not passed stringent fire testing. Fire exit hardware. Fire exit hardware is a type of exit device that is limited to being installed on fire-rated door leaves that bear a physical label that states, "Fire door to be equipped with fire exit hardware." These special labels indicate that the internal construction of the door leaf is designed to support the application of fire exit hardware. When the fire exit hardware devices are installed on fire doors that do not bear the required label, or when fire doors are discovered that are labeled for fire exit hardware but have latching hardware devices other than fire exit hardware devices, immediate corrective action is required. Less bottom rod bolt option. Certain applications of pairs of swinging fire doors are permitted to be used without an active latching device installed in the bottom of one or both of the door leaves. This option is commonly referred to as less bottom rod or less bottom bolt. The less bottom rod, less bottom bolt option is restricted to a specific fire-rated door leaves that have been tested and listed for that application. In this scenario, an auxiliary fire device, referred to as a fire pin, is installed into the edge or bottom of the door leaves. Under normal operating conditions, the pin is held in the retracted position by a fusible covering, which is designed to release the pin when exposed to extreme temperatures of a fire. Once released, the pin is projected under spring tension into the opposing door leaf or the floor, which fixes the door leaf in place. To clarify this situation, fire pins are not released until the temperature of the core of the door is sustained above 400 degrees Fahrenheit, approximately, which requires the temperature on the fire side of the assembly to be well above 400 degrees Fahrenheit, at which point the assembly is no longer meant for ingress or egress. Rather, it becomes a rigidly fixed barrier that is designed to protect the structural integrity of the building from further damage. Auxiliary hardware. Auxiliary hardware items that interfere with or prohibit the operation of the door leaf need to be removed immediately. Perhaps the most frequently misused item of hardware is the ubiquitous kick-down door holder, which is used to hold open self-closing doors. These types of door holders are relatively inexpensive and are readily available, which increases the likelihood of their misuse on fire door assemblies. Hardware items such as overlapping astragals are sometimes used on pairs of doors to close the gap between the meeting edges of the door leaves. However, overlapping astragals require the active door leaf to be opened before the inactive door leaf, which is why they are specifically prohibited in paragraph 6471 of NFPA 80. Let's read that again. Hardware items such as overlapping astragals are sometimes used on pairs of doors to close the gap between the meeting edges of door leaves. However, overlapping astragals require the active door leaf to be opened before the inactive door leaf, which is why they are specifically prohibited in the paragraph 647 of NFPA 80. Field modifications. The term field modification refers to work that involves cutting, welding, planing, trimming, and otherwise modifying fire-rated door leaves and door frames that is performed on site, rather than in a shop that is properly authorized by a testing agency, licensed by the manufacturers of the components, and staffed with personnel who are trained to perform such work. Many fire door assemblies have been ruined in the field by improper modifications that destroyed the integrity of their fire protection properties. Section 413 of NFPA 80, appurtenances, describes the type of modifications that are required to be performed in accordance with the manufacturer's inspection service procedure and under label service. Paragraph 4131. And those modifications that can be performed at the job site. Paragraphs 4132, 4133, 4134 as part of the typical installation process. Significant modifications made to a fire door assembly more than likely violate the labeling requirements of the assembly. In some cases, it might be possible to repair the assemblies, but replacing the door leaves might be the best, most expedient, and least expensive solution for restoring a fire door assembly to its original condition. In cases in which the modification work was performed well, it might be difficult for an inspector to determine that the modification had been made to the assembly. However, certain types of modifications are blatantly obvious and need to be corrected upon discovery. For example, door leaves that have been poorly trimmed in height often exhibit rough, uneven, or jagged edges and are telltale signs of cutouts in door frames to receive electric strikes. These cutouts are sometimes oversized, uneven, or otherwise poor fitting, which are telltale signs of field modifications. Similarly, installing door position switches that are not designed for use on fire door assemblies violates the labeling requirements of the assemblies. In the course of performing routine maintenance on door assemblies, untrained personnel can inadvertently violate the labeling requirements of the assemblies. Work such as removing locks and replacing them with fire exit hardware devices or vice versa might solve the functional need of the occupants, but it might destroy the integrity of the door assembly. A good rule of thumb for determining when a modification is in danger of violating the labeling requirements of an assembly is when it requires drilling new holes, removing sections of material, pockets for mortise locks or through holes for board locks, cutting in vision lights, etc., or trimming doors in height or width. In these cases, the modification should not be made to the assembly unless formal approval of the work is granted in accordance with NFPA 80's provisions for field modifications. Okay, moving on to L on page 22, gasketing and edge seals. Many wood fire doors installed in compliance with the 1997 edition of the Uniform Building Code or any edition of the International Building Code are required to have intumescent seals when they are placed in assemblies that are protecting the path of egress, corridors and stair towers, etc. The intumescent materials might be built into the door leaves or surface applied to the door frame, depending on the components used in the assemblies. Additionally, gasketing might be required by the applicable building, fire, or life safety code to retard the spread of smoke and gases during a fire. NFPA 80 requires these gaskets and seals to be inspected to verify that they are in contact and in good condition. Soffit-applied smoke gasketing and seals are intended to continuously close the gap between the door and frame along the full height of the door and across the top of the door. Installers frequently cut and notch the gasketing and seals to accommodate soffit-applied hardware items such as strikes and surface vertical rod fire exit hardware and brackets for parallel arm door closers. when the gasketing material or its attaching channel is cut or notched to accommodate other hardware items, it cannot be expected to perform its intended function under fire conditions. In this case, the gasketing needs to be removed and replaced, which might also require the removal, reinstallation, and/or replacement of individual hardware items. M. Signage. Large institutions and facilities often use signage to identify room usage within the structures. Section 414 of Nfpa 80, titled Signage, lists requirements for applying signage to fire door assemblies. Care should be exercised during the visual inspections to confirm that existing signage is confirm the existing signage is installed in compliance with these requirements. Signage is not permitted to be attached to the door leaves with screws or nails or any other means of fastening that penetrates the surface of the doors unless the screws or nails are included in the published listing of the signage. Additionally, the physical size of sign or signage applied to the fire door leaf is restricted to being no larger than 5% of the total surface area of the door leaf. This restriction is for the total area of the door leaf, which might be covered by one or more signs. Signage is prohibited from being attached to glazing materials. NFPA 4143. Additional inspection items. In addition to the checklist of inspection items outlined in Section 5235, there are several other items that need to be verified during the inspection process. Protection plates. Auxiliary hardware items like armor, kick, mop, and stretcher plates and edge guards are often installed long after fire door assemblies have been in place. These are frequently used to conceal damage to the surface or edges of fire doors. Section 645, titled Protection Plates, describes the requirements for installing protection plates on fire doors. Unless the protection plates are specifically labeled or were installed by the door manufacturer, installation of protection plates is restricted to not more than 16 inches above the bottom of the door. To clarify this point, a 16-inch high kick plate that is not installed flush with the bottom of the door technically does not comply with NFPA 80's requirement, since a portion or all of the kick plate is installed more than 16 inches from the bottom of the door. As an aside, that also includes stretcher plates. A 4-inch tall stretcher plate installed at the standard stretcher plate height, that's going to violate NFPA 80. Plant-ons and laminated overlays. Plant-ons and laminated overlays are moldings or materials that are attached to the faces of the door leaves to enhance the appearance of the doors. Paragraph 4131 requires the installation of plant-ons and overlays to be performed in conformance and accordance with the manufacturer's inspection service, procedure, and under label service. Materials attached to the face of the fire door leaves affect their performance under fire conditions. Some materials have an extremely detrimental effect. For example, laminating wood materials to a fire door leaf increases the fuel load of the door since flames will consume the wood materials. Likewise, adding large armor plates to wood fire doors might cause the door leaves to fail due to the increased stresses that are exerted on them by the heat induced by expansion of the metal plates. Another area of concern regarding plant-ons and overlays is their means of attachment. Materials attached with adhesives might fall away from the door when exposed to intense heat, which alleviates the concern for increased fuel load. However, screws, nails, and other means of fastening that penetrate the surface of the door leaf might compromise the fire protection properties of that door leaf. Consequently, the door manufacturer needs to be consulted to determine whether the integrity of the door leaf has been compromised by the application of plant-ons. Shimming. Shimming is a common technique of adjusting the clearances between the top and vertical edges of the door frame by inserting thin sheets of material behind the hinge leaves. Paragraph 6434, shimming, states when required to meet the clearances stated in 6317, the shimming of hinges using steel shims shall be permitted. During the visual inspection of fire doors, hinges that have been shimmed improperly are usually readily visible and might require corrective action to replace the shim material with steel as required. Other materials such as pressed cardboard and aluminum flashing are sometimes used as shim material but will not withstand sustained exposure to the extreme heat of a fire, causing the door assembly to fail prematurely. Prevention of door blockage. One of the most frequently cited violations issued for swinging fire doors is for blocked door leaves, especially door leaves that are required to swing in the direction of egress. Boxes, equipment, and other items are sometimes stacked near or on in front of a fire door assemblies, blocking the occupant's approach. Worse materials piled against the pull side of egress door leaves restrict or prevent the movement of the door leaves, which could result in serious injuries and fatalities. In the 2010 edition and earlier editions of NFPA 80, Section 5.2.13, Prevention of Door Blockage, requires the areas around the door openings to be kept clear of materials, equipment, furniture, or any other items that interfere with or block the travel of the door leaves. In buildings where there is a likelihood of interference with the operation of the door travel, NFPA 80 requires a barrier to be constructed to protect the immediate area around the door. Blocking the door leaf in the open position is specifically prohibited. Door chocks, wedges, and kick-down door holders provide convenience to the occupants by holding the door leaves open. However, the occupants typically are unaware that they are completely defeating the assembly's ability to protect them in a fire. Note, the Prevention of Door Blockage section of NFPA 80 does not appear in the 2013 edition. It is unclear as to why it was removed. It might have been due to an oversight that occurred during the reorganization of Chapter 5 for the 2013 edition. Regardless of the reason why this section does not appear in the 2013 edition of NFPA 80, the Model Building, Fire, and Life Safety Codes require the areas on either side of door assemblies to be kept free of obstructions. Most likely, the Prevention of Door Blockage section will reappear in the 2016 edition of NFPA 80. Section E, Painted Doors, Frames, and Hardware. Over time, layers of paint can accumulate to the point at which it interferes with or even prohibits the function of moving parts such as hinges and door closer items. NFPA 80 paragraph 523 states, fusible links, release devices, and other movable parts shall not be painted or coated with other materials that could interfere with the operation of the assembly. Hardware items with excessive paint buildup cannot be cleaned, Hardware items with excessive paint buildup need to be cleaned or replaced. Operational requirements for swinging doors with builder's hardware. Regardless of when swinging doors with builder's hardware were installed, there are three main operational requirements that the majority of assemblies are required to meet under fire conditions. They are required to swing freely. They are required to be automatically self-closing. Let's start that over. They are required to swing freely. Number 2, to be self-closing or automatic closing or power operated. And 3, positively latch in the closed position. In certain applications approved by the AHJ, the closing device can be omitted. NFPA 80, paragraph A6411. I would expect that to refer to a pair of doors in an electrical closet where there's no human occupancy on the other side for the inactive leaf of a pair. Acceptance testing of fire door assemblies. As previously discussed, NFPA 80 requires safety inspections of fire door assemblies to be performed by a qualified person with knowledge and understanding of the operational components of the type of door being subjected to testing. Acceptance testing of fire door assemblies includes operational testing, and visual inspection upon completion of installation or maintenance work. On new construction projects, acceptance testing of fire door assemblies should be completed before the certificate of occupancy is issued and the owner takes possession of the building, space, or structure. In existing buildings, acceptance testing is required upon completion of maintenance work. Prior to performing the operational testing, the door assemblies are required to be visually inspected for deficiencies that might create a hazard during the testing. Any such deficiencies should be corrected before performing the operational testing. Paragraph 5233 states, acceptance testing shall include closing the door by all means of activation. In other words, acceptance testing of fire door leaves that are arranged for automatic closing or that are power operated require the inspectors to verify that the doors close completely under all conditions, which means that some of the operational testing needs to be coordinated with the periodic testing of other systems, such as a fire alarm system. You could have hold open devices, and the fire alarm there's an input on the power supply from the fire alarm. That the fire alarm would need to be tested, as the fire panel would need to be tested to make sure it triggered the power supply to open the circuit to close the doors. Each iteration of acceptance testing is required to be fully documented in accordance with Section 522. Acceptance testing records are required to be maintained for the life of the assembly. See paragraph 5221. That's important. Each iteration of acceptance testing is required to be fully documented in accordance with Section 522, and acceptance records are required to be maintained for the life of the assembly. Acceptance testing of self-closing doors. The majority of swinging fire doors are designed to be self-closing. Generally, they are comprised of mechanical hardware that have a hydraulic door closer, whether surface-mounted or concealed, that controls the opening and closing speed of the door leaves. Some single-leaf swinging fire doors have labeled spring hinges that close the door leaf. In both cases, the door leaf normally rests in the closed position. Operational testing of self-closing door assemblies is straightforward. The door leaves are required to move to the completely closed position when operated from the full open position. Item 6 under Section 52352 states, the active door completely closes when operated from the full open position. In the context of this requirement, the term full open is intended to require the door leaves to be opened as far as possible, which might be only 90 degrees for door leaves that open against a wall or a partition, or as far as installed hardware permits, such as 110, 140, or even up to 180 degree. Assuming the operational test is successful, the inspectors need to open the door several more times to witness the closing device's ability to reliably close the door leaf every time the door is opened. Acceptance testing of automatic closing swinging doors. As previously stated, acceptance testing of automatic closing swinging door leaves shall include closing of the door by all means of activation. Nfpa 805233. Swinging fire doors installed in cross-corridor applications are often electrically held in the open position for the majority of their lifespan. They are designed to automatically close under fire conditions. Magnetic door releases mounted to the walls or floors are commonly used to hold the door leaves in the open position. Electromechanical controlled door closers are also used to hold open the door leaves. Both of these types of hold open devices are required to be tied into the fire alarm system, including other systems such as water flow alarms and carbon dioxide release systems. The door leaves are immediately released when the alarm system is actuated by fire, heat, or smoke detectors at the door assemblies or upon loss of power to the hold open devices. Once released, the door leaves become self-closing and move to the completely closed position. Acceptance testing of automatic closing doors include the following tests. activation by the fire alarm system, activation by the fire, heat, and or smoke detectors, simulation of loss of power to the hold open device, manually pulling the door leaves from the hold open position, opening the doors from the closed position to the full open position. And the activation by fire, heat, and or smoke detector may require coordination with the testing of these other systems. Section 524, periodic inspection and testing, requires the automatic closing devices to be reset in accordance with the manufacturer's instructions. Acceptance testing of power-operated swinging doors. That's the third type. Manual, automatic closing, and then now power-operated. Operational requirements for power-operated doors are found in paragraph 6134 of Nfpa 80, Power-Operated Fire Doors, which states, power-operated fire doors shall be equipped with a releasing device that shall automatically disconnect the power at the time of fire, allowing a self-closing or automatic device to close and latch the door regardless I've lost my place. Power-operated fire doors shall be equipped with a releasing device that shall automatically disconnect the power operator at the time of fire, allowing a self-closing or automatic device to close and latch the door regardless of power failure or manual operation. Acceptance testing of power-operated swinging door leaves is similar to the testing of automatic door leaves in that the inspectors need to witness the closing of the door by all means of actuation. Acceptance testing of power-operated swinging doors includes the following tests. Activation of the fire alarm system interrupts power to the automatic door operators. Activation of the fire, heat, and or smoke detectors where applicable interrupts power to the automatic door operators. Simulation of loss of the power to the automatic door operators. Manually opening the doors from the closed position to the full open position when there is no power to the automatic door operators. Some of those methods are going to require coordination with the testing of other systems. The door leaves of power-operated door assemblies are required to become self-closing when the power to the automatic door operator is interrupted. Latching hardware, mechanical or electrically controlled, is required to positively latch when the door leaves closed during the acceptance testing, simulating their function under fire conditions. Latching of swinging fire doors. The most critical aspect of the acceptance testing for swinging fire doors is to ensure that they positively latch in the closed position, just as they are required to do under fire conditions. Section 6.4.4 of NFPA 80, locks or latches, includes two seemingly opposing requirements that directly affect how the acceptance testing should be administered. First, paragraph 6443 states, all single doors and active leaves of pairs shall be provided with an active latch bolt that cannot be held in a retracted position as specified in the individual manufacturer's published listings. Subsequent to that requirement, paragraph 64433 states, latching arrangements that do not provide positive latching in the normal mode shall be permitted to be used provided that in a fire emergency, the door becomes positively latched by means of an automatic fail-safe device that is activated by an automatic fire detector. So 6443 says, all single doors and active leaves of pairs of doors shall be provided with an active latch that cannot be held in a retracted position as specified in the individual manufacturer's published listing. The subsequent paragraph says you got to have a latch. The first one is, and you can't keep it dogged. Okay, that's simple. Second paragraph says latching arrangements that do not provide positive latching in the normal mode shall be permitted to be used provided that, in a fire emergency, the door becomes positively latched by means of an automatic fail-safe device that is activated by an automatic fire detector. The first requirement is specifically designed for fire door assemblies with mechanically operated latching or locking hardware devices. These products are required to positively latch each time the door leaf returns to the completely closed position, no exceptions. The latter requirement applies to many of today's modern fire door assemblies that are automated with electrically controlled latching or locking hardware and automatic door operators. The requirements listed in the subsequent 64433 are designed to accommodate these modern door assemblies. During normal non-fire conditions, the latching mechanisms are held in the retracted position, allowing the door leaves to be opened and closed by automatic door operators. I'm thinking electrified dogging on a fire-rated exit device. That's what I'm thinking. However, the power to the system that controls the latching hardware is required to be interrupted when the fire alarm or other building alarm system is actuated. Latching mechanisms immediately return to the active state and positively latch the door leaves in the closed position. So my only problem with the subsequent statement, latching arrangements that do not provide positive latching in the normal mode shall be permitted to be used, provided that in a fire emergency the door becomes positively latched by means of an automatic fail-safe device. I would probably call it an automatic fail-secure device, meaning power cut, it's locked. That is activated by automatic fire detector. I'm sure that'll become clear in the class. Fire protection versus accessibility. Since the enactment of the Americans with Disabilities Act in 1990, building owners, property managers, and AHJs have struggled with balancing the need for fire door assemblies to completely close and latch the requirements of the ADA. More specifically, the Americans with Disabilities Act accessibility guidelines and ANSI ICC A117.1, Accessible and Usable Buildings and Facilities, comprise the two main standards for accessibility requirements that restrict the opening force of accessible door assemblies to not more than 5 pounds of force. In many cases, hydraulic door closers with reduced opening forces do not have adequate closing power to reliably close both fire doors. As a technical support genius at LCN told me, with a reduced opening force comes a reduced closing force. Both Americans with Disabilities guidelines and A117.1 specifically exclude the reduced opening force requirements for fire door assemblies in deference to their fire protection requirements. What that means is if you've got a fire-rated door and you cannot make it handicap compliant, that's going to have to be the way it is. The fire code requirements is paramount to the needs of compliance with handicap code. All right, section 5. As we move bravely and courageously forward. Inspection reports and record keeping. Documentation safety inspections. One of the most important aspects of the safety inspections of fire door assemblies is how the acceptance testing and periodic safety inspection and testing reports are documented and maintained. NFPA 80 contains a list of information that is required to be recorded on the inspection reports, as well as the retention periods for the records. Section 5.2, Inspection and Testing, requires inspection records to be signed by the inspector and kept on site for the AHJ's review as part of the AHJ's routine inspections for the buildings in its jurisdiction. Retention of inspection records. Acceptance testing records, the safety inspections, and operational testing required following installation and maintenance work are required to be retained for the life of their respective door assemblies. Newly installed fire door assemblies, whether installed during the construction of a new building, structure, or space, or those that are replacing original door assemblies, are required to be inspected and operationally tested following installation to confirm that they comply with NFPA 80 and function properly. Acceptance testing is also required following the completion of maintenance work, which might be as simple as painting the doors and frames, or as significant as replacing or installing major hardware components such as hinges, latching hardware, and closing devices. According to paragraph 5222, records of periodic safety inspections and testing are required to be retained for a period of at least 3 years. So, your important differentiation happening there. What they're saying is the acceptance records, the safety inspections, and operational testing required following installation and maintenance work, you keep forever. So when it's new or when it's been maintained, you keep it forever. The annual inspection records have to be kept for 3 years. One of the reasons for requiring the inspection records to be maintained for a minimum period of time is that the AHJ is not usually able to visit each building in its jurisdiction each year. It is important to understand that building owners and property managers need to retain the inspection records for each of the intervening years between the AHJ's official visits. In other words, while NFPA 80 might recommend a minimum period of 3 years for retaining the inspection records, owners and property managers need to be able to show that the inspections occurred on schedule in each of the years between the AHJ's visits, which might be once every 5 or more years. The annex comment, paragraph A5222 in Annex A, refers to a retention period of 7 years for inspection records to allow the AHJ to assess the maintenance history of the door assemblies in a building. This type of history might be needed if the owner desires to transition to a performance-based inspection program at some point in the future. Inspection record medium, acceptance testing records, and periodic safety inspection and testing records are permitted to be recorded on paper or in digital format that is acceptable to the AHJ. Whichever medium is selected for recording the inspections, the records need to be stored in a manner that will survive the retention period. As of the writing of this guide, there are several computer-based software programs that are designed to document the safety inspections of fire and egress door assemblies. One of the important features that should be considered when looking at software programs is the ability to prevent the inspection records from being altered after they have been verified and completed. A main advantage of door assembly inspection software programs is that they have the ability to collate all of the information and create lists of corrective actions that need to be performed to bring the door assemblies into compliance. Data for inspection records. Paragraph 5224 in NFPA 80 contains a list of information that is required to be recorded for acceptance testing and the periodic inspection and testing reports. Some of the information is basic in nature. I have a little problem here with one of my monitors. Oh boy. Okay. I'm not able to get to my monitor that is controlling what I'm doing. Okay, now it's fired back up. Okay, now we're back. Okay. Do forgive me. A little lapse there in what we were working on. Waiting for the computer to come back with its monitors. Okay, we're back in business. The monitors turn off at 15 minutes, and sometimes when I immediately force the computer to wake back up, a monitor will say, you know what, I'm not ready to wake up. I'm going to take a little nap. So, all right. Nfpa 80, paragraph 5224, contains a list of information that is required to be recorded for the acceptance testing and the and the periodic inspection and testing reports. Some of the information is basic in nature, that is the date of the walkthrough of the inspections occurred, the name and address of the building and facility, the name of the inspector, and the name of the inspector's company. In addition, the inspection reports are required to include the following information: door number or other identifier that is unique to the door assembly, door location of the door assembly in the building, structure, or space, a description of each door assembly, swinging, sliding, overhead, access, or other type, an individual record for each inspected door assembly, verification of the visual inspection and operational testing of each assembly, a list of deficiencies that require corrective action. Maintenance reports. Although NFPA 80 does not list requirements for maintenance records at the present time, a paperwork trail that documents when and how the deficiencies that were recorded in the inspection reports were corrected will be immensely helpful when assessing the effectiveness of a building's maintenance program over an extended period of time. The maintenance reports should include the following information: date the corrective actions were made, name of the person or persons performing the work, the door number of the assembly that was repaired, reference to the inspection report that documented the deficiencies. Okay, so that's important. The date you fixed it, who fixed it, what door was fixed, and what report you're referring to that made you go fix it. Additional information for inspection reports. One of the most valuable tools that can be used to document the safety inspections is a digital camera. Pictures that show certain types of deficiencies can be extremely helpful, especially when compared to pictures of the assemblies after the corrective actions have been completed. As the old saying goes, a picture is worth 1,000 words. Okay, so now we're moving to Section 6, NFPA 101, Life Safety Code Inspection of Door Openings. It is important to understand that NFPA 101's inspection requirements are designed to complement the inspection requirements of NFPA 80, standard for fire doors and other opening protectives. As we will discuss in more detail later, NFPA 101 directly incorporates NFPA 80's inspection requirements for fire door assemblies into its requirements. After all, it makes sense to verify that the door assemblies are functioning properly while at the same time ensuring that their life safety functions are not compromised. Many non-fire rated egress doors provide equally important life safety functions that serve to protect the occupants. For example, consider the door assemblies that are installed in stair towers of high-rise office, apartment, or hotel buildings. The door assemblies leading into the stair towers, above and below the level of discharge, most likely are fire door assemblies, which are subject to NFPA 80's safety inspection requirements. In many cases, the exterior door assemblies at the level of discharge from the stair towers are not fire rated and therefore are not subject to NFPA 80's inspections. Consider the consequences that might arise in situations in which the building's occupants are not able to leave the stair towers due to malfunctioning or non-functioning door assemblies at the level of discharge, especially in panic situations. NFPA 101 Life Safety Code might not be the prevailing model code that is enforced by the applicable AHJs in many cities, counties, and states. However, NFPA 101 is frequently used as a fire prevention code. Its requirements are applied to buildings of specific occupancy types like schools, hospitals, and other healthcare facilities. In some cases, school districts have adopted portions of NFPA 101 for the inspection and maintenance of the means of egress and periodic fire drills. Inspection requirements for door assemblies first appeared in the 2009 edition of NFPA 101 and were updated in the 2012 edition. The discussion that follows is based on the requirements of the 2012 edition as they clarify the types of door assemblies that are subject to periodic safety inspections. It is recommended that you refer to your copy of the 2012 edition of NFPA 101 as you progress through this section of the guide. Occupancies that require NFPA 101 safety inspections of door openings. In order to understand the full scope of NFPA 101's requirements for safety inspections of door assemblies, it is necessary to discuss how NFPA 101's requirements are intended to be applied. Chapter 7, Means of Egress, contains baseline requirements for the design, construction, protection, and maintenance of all means of egress in all types of buildings, spaces, and structures, protecting the life safety of occupants during normal, operating, non-emergency conditions, and providing for their safe evacuation during a fire, flood, earthquake, or other panic-inducing incident is the main focus of NFPA 101. At the same time, NFPA 101's requirements are designed with the occupant's need to maintain security from unauthorized ingress and intrusion in mind, while making ingress and egress accessible to persons with physical disabilities. Unlike other model building codes and fire codes, NFPA 101 is comprised of four main parts. Part 1, the base chapters, chapters 1 through 4, and then 6 through 11, and chapter 43. Part 2, chapter 5, performance-based option. Part 3, the occupancy chapters, and part 4 are the annexes. From what I know of NFPA 101, if you understand the four main parts, you can quickly navigate to the information that you need. So the majority of it is listing all of the occupancies, part 3, which is chapters 12 through 42. So much of the document is listing every individual different type of occupancy and whether it's a new or an existing structure. So it's less of a overwhelming document when you look at it, in the sense that the bulk of it applies to material that may not apply to your exact situation at that exact moment. Anyway, part 3, the occupancy chapters. Part 4, the annexes. The provisions and requirements of part 1 are subject to application in the occupancy types in part 2. For example, section 7216, special locking arrangements, contains requirements for door assemblies that are equipped with delayed egress locking systems, section 72161, but these types of door assemblies are only allowed in the occupancies that explicitly permit their use. There are two phrases used in part 1 that indicate how specific provisions and requirements are applied elsewhere in NFPA 101. The first phrase, where permitted, in chapters 11 through 43, is used in instances where the requirements are only allowed to be used in the occupancy types that explicitly permit those applications. The second phrase, unless prohibited by chapters 11 through 43, is used where the requirements are intended to be applied to every type of occupancy except those occupancies that explicitly disallow the application. In the case of safety inspections of door assemblies, paragraph 7211.15.1 states, Where required by chapters 11 through 43, the following door assemblies shall be inspected and tested not less than annually in accordance with 721.15.2 through 721.15.8. A quick study of NFPA 101's index reveals that the following occupancy chapters require safety inspections of door assemblies. Chapter 12 and 13, new and existing assembly occupancies. New and existing educational occupancies, which are 14 and 15. New and existing daycare occupancies, 16 and 17. Residential board and care occupancies, 32 and 33. Assembly occupancies are incorporated into many different types of buildings, structures, and spaces. In most cases, the requirements for assembly occupancies become applicable when the occupant load for a room or space is designed for 50 or more persons. For example, the large meeting rooms and ballrooms in hotels are classified as assembly occupancies, even though the primary occupancy type of the building is classified as a hotel. Likewise, restaurants with maximum occupant loads of 50 or more persons are also classified as assembly occupancies. Similarly, recreational rooms and spaces in dormitory and apartment buildings are classified as assembly occupancy when the occupant load accommodates 50 or more persons. Schools for children in kindergarten through the 12th grade, sometimes referred to as K-12 schools, are classified as educational occupancies. School cafeterias, auditoriums, gymnasiums, natatoriums, and other large rooms are classified as assembly occupancies when the occupant load is 50 or more persons. A common misconception is that university buildings and classrooms are subject to the requirements of educational occupancies. Generally, individual university classrooms are classified as business occupancies when the occupant load is less than 50 persons, and are classified as assembly occupancies when the occupant load is designed for 50 or more persons. Places used for child daycare, nursery schools, and adult daycare are subject to the requirements for daycare occupancies. Residential board and care occupancies are generally required, Residential board and care occupancies are generally buildings that are used for housing elderly persons, buildings that house persons rehabilitating from alcoholism, drug abuse, or mental health problems, assisted living facilities, and buildings for physically and mentally handicapped persons who require personal but not medical care. Dining rooms, cafeterias, and recreational rooms in these types of buildings are usually considered to be assembly occupancies when the occupant load is designed for 50 or more persons. Accordingly, NFPA 101 safety inspections for door assemblies become applicable to many different types of buildings where the above-mentioned occupancies are located and NFPA 101's requirements are enforced. Note, for some complete description of these and other occupancy types, refer to Annex A in NFPA 101, starting with paragraph A6121. New or existing construction. One of the differences between the inspection requirements of NFPA 101 versus those of NFPA 80 is that some of the NFPA 101's requirements for existing construction vary from the requirements for new construction. There are chapters dedicated to new and existing construction. Door assembly inspectors need to be aware of these differences and understand when one set of requirements takes precedent over the other. As with NFPA 80's safety inspections, door assembly inspectors need to bear in mind the code requirements that were applicable at the time of installation when applying NFPA 101's requirements. In cases in which the original door assemblies are maintained in working condition, They should be inspected to the code requirements that were in effect at the time of installation. Door assemblies that have been replaced or that have required significant repair, such as replacing door leaves or replacing glazing materials, should be inspected in accordance with the code requirements that were in effect at the time of the replacement or repair work. Fire-rated swinging door assemblies. It is important to be aware that NFPA 101 requires fire door assemblies, including swinging door fire assemblies with builder's hardware, to be installed in accordance with NFPA 80, standard for fire doors and other opening protectives. See paragraph 8331. As might be expected, NFPA 101's requirements for safety inspections of door assemblies are directly applicable to swinging fire door assemblies that are also subject to the safety inspections of NFPA 80. Accordingly, NFPA 101's safety inspections are permitted to be performed concurrently with NFPA 80's inspections. In fact, it makes a great deal of sense to perform NFPA 80's and NFPA 101's inspections at the same time. Dual inspections save time, reduce records keeping and other administration duties and costs, increase consistency, and reduce the costs of the inspection and testing surveys. Smoke door assemblies. Many of the 1/3 hour, 20-minute, fire-rated door assemblies are also classified as smoke door assemblies. The labels on the door leaves include the S mark to indicate that they were tested for use in smoke door assemblies. In order for the S mark to be valid, supplemental gasketing products, not intumescent gasketing, are required to be installed on the door frame. Higher rated fire door assemblies are frequently used in locations that require them to be classified as smoke door assemblies. Section 72115, inspection of door openings, requires smoke door assemblies to be inspected in accordance with NFPA 105, standard for smoke door assemblies and other opening protectives. Note the 2010 and 2013 editions of NFP 105 do not contain specific inspection requirements for smoke door assemblies. However, the soon-to-be-released 2016 edition of NFPA 105 most likely will contain formal inspection requirements for smoke door assemblies. Typically, door assemblies that are installed at fire separations are required to be smoke leakage rated, in addition to being fire rated. For example, door assemblies installed in horizontal exits that are in fire barriers that are also smoke barriers are required to be smoke leakage rated. Likewise, door assemblies that protect an area of refuge are required to be smoke leakage rated. See paragraph 7, 2, 12, 3, 4, 1. Interestingly, door assemblies that are installed in smoke barriers are not required to be fire rated. So that said, interestingly, door assemblies that are installed in smoke barriers are not required to be fire rated unless the occupancy type requires the smoke barrier to be of fire rated construction. In other words, a fire barrier that is also used as a smoke barrier. Since these types of door assemblies are not fire rated, they are not subject to the requirements of NFPA 80. Technically speaking, when the occupancy type does not require the door assemblies to be smoke leakage rated, they are not subject to the requirements of NFPA 105. In cases in which the smoke door assemblies are not required to be fire rated, the door leaves will not bear any type of physical label, such door assemblies are usually not referred to as being smoke leakage rated, a term that triggers the requirements of NFPA 105, but rather as smoke resistant doors. Door assemblies that resist the passage of smoke and that are not fire rated. This is a subtle but important distinction that door assembly inspectors need to bear in mind, as only the smoke barrier doors that are required to be smoke leakage rated are subject to NFPA 101's inspection requirements. In order smoke door assemblies to be effective and perform their intended function, the door leaves need to be closed at the time of fire. Accordingly, NFPA 101 requires doors that are installed in smoke barriers to be either self-closing or automatic closing. See paragraph 8544. In most cases, latching door hardware is required on smoke barrier door assemblies, which is consistent with NFPA 80's requirements for fire-rated door assemblies. Non-fire-rated smoke door assemblies might not be required to have latching hardware. Remember, NFPA 80's requirements for fire-rated door assemblies take precedent over all other requirements, even the requirements of NFPA 101 and NFPA 105. Regardless of fire rating, smoke leakage rated door assemblies are required to be tight-fitting in their frames. Paragraph 8541 states, doors and smoke barriers shall close the opening, leaving only the minimum clearance necessary for proper operation, and shall be without louvers or grills. The clearance under the bottom of a new door shall be a maximum of 3/4 inch. Neither NFPA 101 nor NFPA 105 provides specific criteria that can be used to determine when a door leaf is considered to have only the minimum clearance necessary for proper operation, which makes this requirement subjective to interpretation in the field. Depending on the construction, whether it's hollow metal or flush wood, etc., and configuration, meaning beveled or square vertical styles, of the door leaf, the minimum clearances needed for the door leaves to open and close without interference with the door frame varies. For instance, square-edged hollow metal door leaves usually require an opening clearance of nearly 1/8 of an inch at the vertical stiles, whereas flush wood doors with beveled vertical stiles typically require operating clearances of approximately 1/16 of an inch. In the absence of any minimal operating clearance specifications in NFPA 101 or NFPA 105, it seems reasonable to apply the clearance requirements from NFPA 80 to smoke leakage rated door assemblies. Generally, smoke leakage rated door assemblies are required in the following locations: areas of refuge, elevator lobbies, fire barriers that are also smoke barriers, fire separations, horizontal exits. Functional testing of door assemblies. Individuals performing NFPA 101 safety inspections of fire and egress door assemblies are required to be able to demonstrate their knowledge and understanding of the operating components of the type of door being subjected to testing. This language is vague and therefore ambiguous as to what levels of credentials, if any, the persons performing NFPA 101 safety inspections are required to provide to building owners and AHJs. Even though NFPA 101's current requirements do not specifically mandate that the safety inspections be performed by a qualified person, NFPA 80's, however, do. Refer to Section 2, General Information of this guide for more information regarding the term qualified person. Accordingly, it stands to reason that the qualified persons who are performing the NFPA safety inspections should also be able to perform the NFPA 101 safety inspections. Inspection of door openings. Section 72115 of Chapter 7, Means of Egress, titled Inspection of Door Openings, lists 4 types of door assemblies that are required to be inspected on an annual basis. Door leaves equipped with panic hardware or fire exit hardware in accordance with 7217. Door assemblies and exit enclosures. Electrically controlled egress doors. Door assemblies with special locking arrangements subject to 7216. Doors with panic hardware or fire exit hardware. We're going to go over those 4 right now. Generally, panic hardware and fire exit hardware devices are only required by NFPA 101 to be used on door assemblies serving assembly occupancies that have occupant loads of 100 or more persons.
door assemblies for educational occupancies, and door assemblies serving high hazard content areas, including electrical vault room door assemblies. Consequently, doors equipped with panic hardware or fire exit hardware, whether required by occupancy or used as a matter of preference, are subject to NFPA 101 safety inspections. Paragraph 72172 requires panic hardware devices to be installed on non-fire rated door leaves and fire exit hardware devices to be installed only on fire rated door leaves. Remember, NFPA 101 requires fire door assemblies to be installed in accordance with NFPA 80, which restricts the installation of fire exit hardware devices to door leaves that bear a label that states fire door to be equipped with fire exit hardware. The requirements work together. Accordingly, fire exit hardware devices are only permitted to be installed on fire-rated doors that are appropriately labeled. Door assemblies in exit enclosures. NFPA 101 describes exit enclosures as providing a continuous, protected path of travel to an exit discharge. Paragraph 71322. Door assemblies installed in exit enclosures are used to protect the path of egress through a portion of the building, structure, or space. Stair towers are a type of exit enclosure. Their construction, such as walls, stairs, railings, etc., is designed to provide time for occupants to safely evacuate during fires or other emergencies. The door assemblies, both fire and non-fire rated, are critical to the occupants' safe evacuation. Corridors that connect multiple stair towers or that extend from an internal stair tower to the outside are other types of exit enclosures. Only door assemblies from normally occupied spaces and corridors and door assemblies that lead to the outside public way are permitted. Spaces that are designed as areas of refuge are located in exit enclosures. Exit enclosures are not permitted to contain equipment other than equipment that is needed in areas of refuge or to be used for storage of any type. Generally, exit enclosures are intended to be free of combustible materials and contents. In the case of door assemblies that are installed in stair towers, Section 72158 and paragraph 72159 contain requirements for locking the stair side of door assemblies and providing for re-entry into the building. Let's start that over. In the case of door assemblies that are installed in stair towers, Section 72158 and paragraph 72159 contain requirements for locking the stair side of door assemblies and providing for re-entry into the interior of the building. Note there are significant differences between NFPA 101's provisions for locking stair tower doors and those in the International Building Code and the International Fire Code. Door assembly inspectors need to be aware of these differences in cases in which NFPA 101's inspections are applied to buildings and structures that were constructed under the IBC. Okay, now moving into electrically controlled egress doors. Electrically controlled egress doors are door assemblies that are equipped with mechanical and electrified hardware devices. Electrified hardware devices might be as simple as electric strikes that are connected to keypads or card readers, or as complex as fully automated door operation that is integrated with electrically controlled latching hardware, electric latch retraction, panic exit hardware, or fire exit hardware. In all cases, electrically controlled egress doors include some form of hardware device that is mounted directly to the door leaves that interrupts power to the locking device when used by the occupants to exit through the door opening. This is an important point to remember when determining when a door assembly should be classified as an electrically controlled egress door assembly or as an access controlled egress door assembly. Access-controlled egress door assemblies are subject to the provisions and requirements of special locking arrangements, Section 72162, and usually are locked by a magnetic lock or a fail-safe electric pneumatic bolt. No interconnected hardware device is mounted on the door leaves that causes the locking device to unlock. Many electrically controlled egress door assemblies include some form of credential reader. We're going to start that paragraph over because I was interrupted with a phone call. In all cases, electrically controlled egress doors include some form of hardware device that is mounted directly to the door leaves that interrupts power to the locking device when used by the occupants to exit through the door opening. This is an important point to remember when determining when a door assembly should be classified as an electrically controlled egress door assembly or as an access-controlled egress door assembly. Access-controlled egress door assemblies are subject to the provisions and requirements of special locking arrangements, Section 72162, and usually are locked by a magnetic lock or a fail-safe electric pneumatic bolt. No interconnected hardware device is mounted on the door leaves that causes the locking device to unlock. Many electrically controlled egress door assemblies include some form of credential reader. Many electrically controlled, keypad, proximity, or biometric. On the non-egress side of the assembly, which leads some AHJs to mistakenly apply the requirements for access-controlled egress door assemblies to these assemblies. Electrically controlled egress door assemblies contains a list of mandatory requirements for these systems. Of particular note, paragraph 72162 explicitly excludes electrically controlled egress door assemblies from the requirements of access-controlled egress door assemblies. Another important point to remember regarding electrically controlled egress door assemblies is that they are permitted to be used in all of the occupancy types. Their use is not qualified by the typical where permitted or unless prohibited statements. In addition, these types of door assemblies might be fire rated, which requires compliance with Nfpa 80 safety inspections. Door assemblies with special locking arrangements. The term special locking arrangements refers to electrified hardware applications that intentionally delay, such as delayed egress locking systems, the egress of occupants under normal, non-emergency conditions, or that might prevent the occupant's egress under emergency conditions. Access-controlled egress door assemblies. These systems are required to permit free egress under emergency conditions or loss of power to the locking devices. In each case, these types of door assemblies are only used in occupancy groups that explicitly permit special locking arrangement applications. Section 7261, Special Locking Arrangements, is comprised of 3 subsections, each containing provisions and requirements that pertain to a specific type of special locking arrangement. The 3 subsections are delayed egress locking systems, access-controlled egress door assemblies, elevator lobby exit access door assemblies locking. So, special locking arrangements are comprised of 3 subsections: delayed egress, access-controlled egress, elevator lobby exit access. Delayed egress locking systems. As the title indicates, delayed egress locking systems are designed to delay the egress of occupancy during normal, non-emergency conditions. Typically, delayed egress locking systems are permitted to prevent the door leaves from opening for a period of 15 seconds. In rare cases, where approved by the AHJ, the delay period is permitted to be 30 seconds. Under fire alarm conditions and upon loss of power, doors that are equipped with delayed egress locking systems are required to unlock in the direction of egress travel, allowing the occupants to open the doors immediately. Delayed egress locking systems might be comprised of delayed egress magnetic locks or delayed egress panic hardware, fire exit hardware devices. The required function of delayed egress locking systems is the same, regardless of the components that comprise the systems. Paragraph 721611 describes the function of delayed egress locking systems. It states, an irreversible process shall release the lock in the direction of egress within 15 seconds or 30 seconds where approved by the authority having jurisdiction upon application of a force to the release device required in 721510 under all of the following conditions. The force shall not be required to exceed 15 foot-pounds. The force shall not be required to be continuously applied for more than 3 seconds. The initiation of the release process shall activate an audible signal in the vicinity of the door opening. Once the lock has released by the application of force to the releasing device, relocking shall be by manual means only. Delayed egress locks. Delayed egress locking systems are only permitted to be used in occupancies of low or ordinary hazard contents, where they are explicitly permitted by the occupancy types. Additionally, the buildings are required to be protected by automatic sprinkler systems or fire detection systems throughout. There are several other requirements listed in Section 72161 that are critical to the function and operation of delayed egress locking systems that are too detailed to include in this guide. Please refer to NFPA 101 for the complete list of requirements for delayed egress locking systems. Access-controlled egress door assemblies. The term access-controlled egress door assemblies brings to mind visions of door assemblies that are equipped with sophisticated electrical hardware devices, state-of-the-art credential readers, and even fully automated door operation. Persons seeking to gain entry into the building, structure, or space need to present authorized credentials, whether it be a PIN, a swipe card, submit fingerprints or handprints, in order to unlock and open the door. While access-controlled egress door assemblies include some form of authorized credentials for people to gain entry, the locking portion of the system is usually accomplished by a magnetic lock or by a fail-safe electrified pneumatic bolt lock. Locking latched hardware or other devices that interrupt power to the locking hardware are not installed on the door leaves. Locking latched hardware or other devices that interrupt power to the locking hardware are not installed on the door leaves. NFPA 101 Section 72162, Access Controlled Egress. A little bit of an interruption there, so we're going to start back at the top of page 38. NFPA 101 Section 72162, Access Controlled Egress Door Assemblies, defines the function and establishes the requirements that such door assemblies must provide and meet. Of paramount concern is the occupant's ability to safely and immediately egress through the door opening under normal non-emergency conditions, as well as in emergency conditions. Requirements for access-controlled egress doors appeared in the Building, Fire, and Life Safety Code as far back as the 1970s. At that time, the term access-controlled had a much different connotation than it does today. Keypads and magnetic stripe Wiegand cards circa 1980 were used primarily to unlock magnetic locks to allow entry. Many of today's electrified hardware functions and devices did not exist when the requirements for access-controlled egress doors first appeared in the codes. Consequently, when a card reader or other authorized credential reader is installed on a door assembly, some people assume that the door assembly is subject to the requirements for access-controlled egress door assemblies when it is, Consequently, when a card reader or other authorized credential reader is installed on a door assembly, some people assume that the door assembly is subject to the requirements for access-controlled egress door assemblies when it is not. Remember, the absence of door leaf-mounted devices that interrupt power to the locking devices is the key factor in identifying access-controlled egress door assemblies, not the presence of credential readers on the entry side of the door assembly. So the difference is what's on the outside versus what's on the inside. It's the inside that's really important here. Remember, the absence of door leaf-mounted devices that interrupt power to the locking devices is the key factor in identifying access-controlled door assemblies, not the presence of credential readers on the entry side of the door assemblies. Magnetic locks are a type of fail-safe locking device that requires electrical power to maintain the locked condition. When magnetic locks are used to secure an access-controlled door assembly, provisions for the occupant's unimpeded egress under normal conditions need to be met. To accomplish this function, a motion detector is required to be installed on the egress side of the assembly that detects occupants as they approach the door, interrupting power to the locking device and allowing the door to be opened. A secondary redundant manual release push button is required to be installed adjacent to the door assembly that allows the occupants to unlock the door in cases in which the detector malfunctions or otherwise fails to unlock the door. NFPA 101 requires the locking devices installed on access-controlled egress door assemblies to unlock upon loss of power to the motion detector and or locking device. As with the other types of door assemblies that have electrified hardware devices, access-controlled egress door assemblies are required to be connected to the fire alarm system. Activation of the automatic sprinkler system also causes the doors to unlock. Please refer to section 72162 in NFPA 101 for the complete list of provisions and requirements for access-controlled egress door assemblies. Elevator lobby exit access door assemblies locking. Elevator lobby exit access door assemblies locking is another classification of special locking arrangements that appears in section 72163 of NFPA 101. The purpose of an elevator lobby exit access door assembly locking system is to prevent unauthorized access to the floor while at the same time preventing occupants from being trapped in the elevator lobby under fire conditions. Most of the provisions and requirements for these types of door assemblies pertain to building systems such as fire alarm and sprinkler systems rather than the function of the hardware devices. The main distinction in this case is that the door assemblies are fire rated, which requires the doors to have positive latching hardware in accordance with NFPA 80. The locking hardware device might be a magnetic lock with a passage latch set, or a fail-safe electrified locking device, such as a mortise or cylindrical lock, that remains latched in the unlocked condition. Let's take a closer look at that. So the locking hardware device might be a magnetic lock with a passage latch, or a fail-safe electrified locking device such as a mortise or a cylindrical lock that still remains latched although the unit is unlocked. So fail-safe. Typically a credential reader or some form, keypad, card, prox reader, biometric reader, is installed on the elevator side of the door assembly to allow authorized entry to the tenant space on the floor. The provisions for other types of special locking arrangements addressed in Section 7216 are expressly prohibited from being applied to elevator, lobby, exit access door assemblies. Please refer to Section 72163 of NFPA 101 for a complete list of provisions and requirements for elevator, lobby, exit access door assemblies locking. Inspecting door assemblies equipped with special locking arrangements. The persons performing NFPA 101 and NFPA 80 safety inspections on door assemblies that are equipped with special locking arrangements need to be able to witness all of the applicable functions that are required by NFPA 101. For instance, where the systems are required to be tied into the fire alarm or other building system, the safety inspections need to include simulating alarm conditions to verify that the door assemblies function as required. This level of functional testing needs to be coordinated or completed during other system-wide testing to minimize disruption to the daily routine of the buildings, structures, and spaces. Checklist of inspection items. Section 721.15.7 lists the minimum conditions and items that are required to be verified during the safety inspections. As a minimum, the following items shall be verified. Floor space on both sides of the opening is clear of obstructions and the door leaves open fully and close freely. Forces required to set the door leaves in motion move to the fully open position do not exceed the requirements of 72145. Latching and locking devices comply with 7215. Releasing hardware devices are installed in accordance with 72151. Door leaves of paired openings are installed in accordance with 721.5.11. Door closers are adjusted properly to control the closing speed of door leaves in accordance with accessibility requirements. Projection of door leaves into the path of egress does not exceed the encroachment permitted by 72143. Powered door openings operate in accordance with 7213. Signage required by 72141.3, 72155, 7216, and 7219 is intact and legible. Door openings with special locking arrangements function in accordance with 7216. Security devices that impede egress are not installed on openings as required by 7215.12. Each of these inspection points requires the persons performing the safety inspections to be extremely knowledgeable of the myriad requirements that affect egress door assemblies. Due to the immense number of components that can be installed on egress, fire-rated and non-fire-rated door assemblies, it is not possible to fully describe each application in this guide. Suffice it to say that in addition to knowing the code and standard requirements for egress door assemblies, the persons inspecting them need to have acquired a great deal of product application knowledge. For example, while the functional requirements for delayed egress locking systems are the same regardless of whether the systems are comprised of delayed egress magnetic locks or delayed egress panic hardware, fire exit hardware, the inspection and testing of the system is determined by the specific components that are installed on the assembly. Additional inspection items. In addition to the previously mentioned list of inspection items, there are a few other items that should be included in the safety inspections, the most important of which are the glass and glazing materials that are installed in the door leaves or in the side light or transom light door frames. Glass and glazing door assemblies. Glass and glazing materials installed in door leaves or in side light door frames are susceptible to damage caused by accidental impact by occupants. Occupants have been injured, sometimes seriously, when they have put their hands, forearms, feet, legs through glass vision panels indoors, which is why the modern building and life safety codes require the use of glass and glazing materials that meet or exceed the requirements for safety materials. Tempered glass, laminated glass, and ceramic or composite glazing materials are usually acceptable for use in door assemblies with large vision panels and side light panels. Another type of glass that was once widely used in door assembly is wired glass. Since 1977, wired glass has been prohibited from being used in non-fire rated door assemblies and other areas where the building and life safety codes required glass and glazing materials to comply with Consumer Product Safety Commission's 16 CFR 1201 standard. However, clear wired glass was the predominant glazing material used in fire-rated door assemblies until recent years, when its use was severely restricted by the building, fire, and life safety codes. Consequently, clear wired glass is installed in many older door assemblies. As far as NFPA 101 safety inspection requirements of door assemblies are concerned, door assembly inspectors need to bear in mind the codes and standards that were applicable at the time of installation. In instances in which the door assembly inspectors witness wire glass installed in non-fire rated door assemblies, the inspectors need to cite its presence as a deficiency that requires corrective action, meaning replacement. Tempered and laminated glass panels are generally acceptable for use in non-fire rated door assemblies. Glass and glazing materials installed in fire-rated doors are required to be individually marked in accordance with paragraph 8342 and table 8342 in NFPA 101. The requirement for individually marked panels of glass and glazing is dependent on the code requirements that were applicable at the time of installation. Generally, glass and glazing in door assemblies that were installed in accordance with the 2006 edition of NFPA 101 were required to be individually marked. Note, NFPA 80 contains separate marking requirements for glass and glazing materials that were installed in fire-rated door assemblies. Its requirements date back to the 1990s. In cases in which the existing glass and glazing materials need to be replaced, the replacement materials are required to comply with the current code and standard requirements. In other words, even when the original building code requirements permitted the use of clear wire glass in fire-rated door assemblies, replacement glass and glazing needs to comply with the codes and standards that are in effect at the time of replacement. Wired glass might need to be replaced with glazing materials that are labeled for use in fire-rated doors and that meet requirements for safety glazing materials. Door assembly inspectors should include a note or comment on their inspection reports when they witness large sections of wired glass panels installed in older fire door assemblies. Technically speaking, undamaged wired glass panels that were permitted under the original building code are not considered to be deficiencies. Even so, owners and property managers need to be made aware of wired glass in their door assemblies, as they are a potential hazard to the occupants. Changes in use or occupancy. Additional inspection items that should be considered part of the NFPA 101 safety inspections include recognizing changes in the building's use or occupancy over its lifetime. Some of the points that door assembly inspectors need to be aware of: minimum clear opening width, egress capacity, direction of the door swing, panic hardware, and fire exit hardware. In most cases, door assembly inspectors should not be tasked with determining that the clear width of a particular door assembly complies with NFPA 101's requirements. However, in older existing buildings where the occupancy use has changed, sometimes more than once, door assembly inspectors need to be able to recognize situations in which the existing door assembly does not meet the minimum clear width for the space that it serves. See section 72121, measurement of clear width. Additionally, changes in the building's use and occupancy, especially changes that increase the occupant load of a room or space, might require new door assemblies that provide adequate egress capacity for the room or space that they serve. See Section 733, Egress Capacity. Generally, building renovations that included merging 2 or more rooms in order to create meeting rooms or other large spaces are considered to be assembly occupancies when the occupant load is designed for 50 or more persons. NFPA 101 requires doors that serve rooms or spaces with 50 or more persons to swing in the direction of egress travel. See Section 72142. Door leaf swing direction. When the occupant load is designed for 100 or more persons, panic hardware, or fire exit hardware devices are required to be installed on the doors. See Section 7217, panic hardware and fire safety hardware. NFPA 101's inspection reports and records keeping. Similar to NFPA 80, safety inspections and testing performed in accordance with NFPA 101's requirements are required to be documented in writing, signed by the inspector and kept on site for periodic review by the AHJ. However, NFPA 101 does not contain requirements as to the level of information that is required to be captured on the inspection reports. Nor does NFPA 101 specify a minimum time period for the retention of the inspection records. In the absence of such requirements and considering that NFPA 101's inspections are tied to the inspections of NFPA 80, it makes sense to apply NFPA 80's inspection report and record retention requirements as guidelines for NFPA 101's inspections. Comprehensive inspection reports can be designed to accommodate both NFPA 101's and NFPA 80's safety inspections, reducing redundancy that would occur if the inspections were recorded separately. Acceptance testing upon installation and following maintenance. Acceptance testing upon installation and following maintenance. Inspections, periodic safety inspections, and ongoing maintenance records of non-fire rated egress doors should be modeled after NFPA 80's reports for fire door assemblies. Okay, now we're moving on to Section 7, Inspector Qualifications, Responsibilities, and Training. Inspector Qualifications. NFPA 80 and NFPA 101 do not require the safety inspections to be performed by third parties, but they do require the individuals performing the inspections to have an acceptable level of knowledge and expertise. As mentioned previously, NFPA 80 requires the safety inspections of fire door assemblies to be performed by a qualified person with knowledge and understanding of the operating components of the type of door being subject to testing. Paragraph 5231. AHJ personnel need to have confidence in the individuals who are performing the safety inspections of fire door assemblies. While NFPA 80 does not explicitly require the inspections to be performed by third-party inspectors, maintenance personnel for a building or facility might not have the necessary experience and training to accurately inspect the door assemblies. Building owners and property management personnel need to be prepared to provide assurance to the AHJ that the persons performing the safety inspections of their fire and egress door assemblies have the requisite level of knowledge and expertise to fully evaluate the condition of the door assemblies in accordance with NFPA 80's and NFPA 101's requirements. Depending on the types of fire and egress door assemblies in the buildings, owners might decide to rely on third-party inspectors to perform these safety inspections. On the other hand, in cases in which owners have experienced maintenance personnel who are capable of performing these safety inspections, training is available from a number of sources. Third-party inspectors. Performing the safety inspections and functional testing is a daunting task for AHJs to add to their already burgeoning responsibilities. When one considers all of the other critical building systems that are equally important to sustaining to sustaining life safety, this is especially true. Inspections of small buildings and facilities with only a few fire and egress door assemblies might take so little time that an AHJ might choose to perform these inspections. On the other hand, inspections of larger buildings and facilities require a great deal more time to perform, time that AHJs are not able to dedicate due to their other responsibilities. Fortunately, there is a group of qualified people ready to perform safety inspections of fire and egress door assemblies. To access a directory of individuals who are certified to perform inspections of swinging fire and egress door assemblies, contact Intertech, the Door Hardware Institute, or the Door Security and Safety Foundation. When considering using third-party fire door assembly inspectors, seek out the individuals with the specific skills and expertise necessary to inspect the types of fire doors and their assemblies that are installed in the buildings and facilities. After identifying the types of fire and egress door assemblies in the buildings, a series of questions can be developed to help select appropriate inspectors. Likely questions might include the following. Which type of fire and egress door assemblies are you qualified to test and inspect? How many fire door assembly inspections have you performed? What type of door assembly inspection training have you completed? Are you certified to perform safety inspections on fire door assemblies? If so, do you have the documentation of your certification? Are you affiliated with any professional organizations that pertain to fire door assemblies? And if so, which professional organizations are they? Does your company offer corrective action services? If not, which companies do you recommend to perform the corrective action services? Do you carry liability insurance? Are you bonded and or licensed? Another good practice to employ when selecting third-party inspectors is to request a list of references from clients of the prospective inspectors. Take time to thoroughly research prospective inspectors before hiring them to perform your safety inspections of fire and egress door assemblies. Inspector responsibilities. Inspectors of fire and egress door assemblies are responsible for performing the safety inspections and operational testing correctly and reporting their findings accurately to the building owner or property manager. They are simply recording and reporting the conditions of the fire and egress door assemblies as of the date and time of the inspections, nothing more. Inspectors are not imbued with the authority to force owners to bring their buildings into compliance, nor are they required to act as agents of the AHJ by reporting non-compliant assemblies directly to the AHJ's office. Only the AHJ has the authority to enforce building fire and life safety code compliance. Remember, under the requirements of NFPA 80 and NFPA 101, building owners and property managers are the parties responsible for making sure that the safety inspections and testing of fire and egress door assemblies take place as prescribed, as well as the subsequent maintenance. Certification for inspectors of swinging fire and egress door assemblies. Intertech, who provides the recognized Warnock-Hersey mark for building products, offers professional certification for individuals performing inspections of swinging fire and egress door assemblies with builder's hardware throughout their Intertech Qualified Personnel IQP Fire Door Inspector Program. In order for fire door inspectors to be eligible to enroll in the IQP program, candidates are required to successfully complete a prescribed series of courses in the annual Fire and Egress Door Assembly Inspection Program, presented by the Door Hardware Institute, DHI, and pass their 4-hour proctored exam, upon which they receive the credentials FDAI. Once enrolled in the IQP program, FDAI inspectors subscribe to periodic audits of their inspection records and are required to maintain their certification through continuing education every 3 years. IQP fire door inspectors are issued photo badge credentials as evidence that they have completed the required training and passed the proctored exam. DHI courses focus on swinging doors with builder's hardware, giving the inspectors a working knowledge of numerous door frame, and hardware products used on these types of fire door assemblies, as well as the codes and standards that affect them. Interested parties are encouraged to contact Intertech or DHI for more information. Fire Door Assembly Inspector FDAI credential. Only individuals who complete the DHI training program that leads to the IQP certification earn the DHI Fire Door Assembly Inspector credential. DHI also offers an extensive education program and 4 levels of professional certification for consultants. 4 levels of professional certification for individuals working in the architectural openings industry. DHI's Architectural Hardware Consultant, AHC, professional certification began under the former American Association of Architectural Hardware Consultants, ASAHC, circa 1940, and is the most established level of certification within its membership. DHI's other professional certifications include Certified Door Consultant, CDC, Electrified Hardware Consultant, EHC, and Architectural Openings Consultant, AOC. The people who hold these certifications have completed hundreds of hours of educational training, accumulated significant on-the-job training experience, and passed rigorous written exams. Each of DHI's certification disciplines requires candidates to complete a prescribed series of classes before they are eligible to sit for their respective certification exams. The core curriculum provides these individuals with detailed training and technical information regarding the myriad of door frame and builder's hardware products, as well as their applications that comprise swinging fire and egress door assemblies. DHI's educational courses are available to all interested parties. For additional information, please contact DHI or visit their website and click on the education link. Locating third-party inspectors, the Door Hardware Institute offers an online directory of individuals who have completed the DHI FDAI door assembly inspection training courses on its website that is free of charge to all interested parties. Similarly, Intertech offers an online directory of companies and individuals who are enrolled in their IQP fire door inspection program on their website. All right. Moving on to Section 8, Performing Safety Inspections. Preparing for the initial inspection. Building owners and property managers need to gather significant information concerning the fire door assemblies within their buildings and facilities before the initial inspection can take place. Facilities with established maintenance programs will already have collected most, if not all, of the necessary information. Identifying fire egress door assemblies. Ideally, maintenance personnel have access to the as-built floor plans from when the building was constructed or last renovated, which illustrate where the fire-rated partitions and walls are located and include door opening schedules. Many healthcare facilities are required to maintain a detailed set of life safety drawings that include the locations and ratings of fire door assemblies. Armed with this level of information, locating and cataloging the fire and egress door assemblies is relatively straightforward. Owners of older buildings might not have access to the original floor plans and door opening schedules, making locating fire door assemblies more difficult. In some cases, the AHJ's office or the office that issued the building permit, if they are not the same entity, might have archived copies of the floor plans, which could be copied and used for these safety inspections. Worst case scenario, the floor plans are permanently misplaced for these buildings. In these cases, the best method of identifying the fire door assemblies is to physically check each door assembly and look for labels attached to the door leaves. Be sure to catalog them as you go and create an updated record of the building's fire door assemblies. Locating fire door assemblies. Interior door assemblies that open into or out of corridors and stair towers are likely fire rated. Likewise, door assemblies placed across corridors typically are fire rated. Door assemblies placed at building separations, such as walls in between existing construction and new construction, are most likely fire rated. Fire doors to rooms within other rooms are most likely difficult to locate. Janitorial, storage, and electrical service closets and mechanical and fire storage rooms can be scattered throughout the building. Finding and cataloging all of the fire door assemblies might be a time-consuming process, but it is a worthwhile investment in improving safety for the building's occupants. Physical labels attached to fire door assemblies. Generally, labels that are attached to fire-rated door leaves are located on the hinge edge of the door and in the hinge rabbet of the door frame at approximately 60" above the floor. Labels are sometimes located on the top edge of the door and or in the door rabbet of the head of the door frame when hardware items, such as concealed leaf continuous hinges, would otherwise cover them if they were placed in their typical locations. Physical labels on door leaves might be made from metal or mylar and are attached by rivets or adhesives. They are approximately 1 inch in height and 3 inches in length. Most metal fire door labels are black, but they might be other colors depending on the issuing laboratory and the manufacturer. Locating and reading the information contained on the labels is necessary to fully evaluate the condition of the door assemblies. When the labels are painted over, it is not possible to read information printed on them, but at least you will have identified the door leaves and door frames as being fire rated. Many labeled hollow metal door frames are marked with embossed or stamped labels rather than physical labels. In most cases, the embossed markings are obscured by layers of paint that have accumulated over time. In order to read the embossments, it is necessary to remove some or all of the paint. Cataloging fire and egress door assemblies. Once all of the fire and door assemblies have been located, an index of these door assemblies should be created so that it can be used for generating inspection, testing, and maintenance records. Each assembly should be assigned a permanent code, number, or door symbol that is unique to the assembly. The following information should be the minimum information listed with each assembly. Number 1, door number, code, or symbol. Assigning individual door numbers can easily be accomplished depending on the building, the numbering sequence. Depending on the building, the numbering sequence might be as simple as 1, 2, and 3. In multiple story buildings, a prefix number or letter 1-1, A1, B1, etc. might be added to the number to identify the floor where the door assembly is installed. Alternatively, other coding schemes can be devised to create identification codes for the door assemblies. The point of the door number is to be able to consistently track each assembly's performance through the inspection, testing, and maintenance programs. In addition to assigning door numbers to the assemblies, barcodes can be used to create a unique code for each assembly. Generic barcodes of various designs can quickly be scanned by handheld devices, such as PDAs, smartphones, tablets, and handheld PCs, into inspection-based software or apps to enter or recall detailed information concerning specific door assemblies. Location of the assembly in the building. The description of the location of the assemblies within the structure should be purposefully simple. For example, door A1, first floor stair tower, indicates where the door assembly is located. Step 3. Type of door assembly. The type of door assembly should indicate whether the assembly is a swinging door with builder's hardware or any of the other assembly types addressed in an Nfpa 80 that are subject to the inspection, testing, and maintenance requirements therein. Fire protection ratings of the assembly. Fire protection rating is typically expressed in hourly ratings. See Annex D of Nfpa 80 for a complete explanation. Door assemblies are rated for 1/3 hour, 20-minute, half hour, 30-minute, 3/4 hour, 45-minute, 1 hour, 60-minute, hour and a half, 90-minute, and 3 hour, 180-minute durations. Step 5. Comments and or remarks. Be sure to record details of fire and egress door assemblies that might appear atypical. For example, oversized fire door assemblies might have a special type of label that is referred to as a construction label, or there might be a certificate of construction on file with the AHJ for that specific door assembly. It is beneficial to research and document these unique openings during the initial inspection so that time will not be spent reconfirming the same details during subsequent inspections. Documenting approved exceptions. Occasionally, custom or specially engineered fire door assemblies are created to suit conditions that are unique to a building specifically or to its structure. These assemblies are constructed using the same materials and techniques as the standard units, but are not technically classified as a fire door assembly, since they have not been formally suggested to since they have not been subjected to fire door tests. Prior to these custom assemblies being installed, the AHJ will require documentation attesting to the construction of the assembly. When the AHJ approves a custom fire door assembly, a formal letter of approval is issued recording the specifics of the approval. Be sure to retain a copy of this approval with the index of door assemblies for future inspection cycles. Performing the inspections. A final step in preparing to conduct inspections is to consult with the AHJ's office to confirm its expectations for the safety inspections and how it intends to enforce compliance with the requirements of Nfpa 80 and Nfpa 101. In most cases, the local AHJ office will have requirements that are specific to its jurisdiction that need to be incorporated into the inspection and testing process. Likely areas of concern are clearances between the perimeter of the door and the door frame, painted, removed, or reinstalled labels, blocking of fire doors in the open position, plant-ons and laminated overlays, significantly damaged or inoperable fire door assemblies. Once all of the initial preparation work has been completed, the next step is to perform the inspection and testing of the fire and egress door assemblies. Regardless of whether the inspections are performed by third-party inspectors or the owner's maintenance personnel, the inspector should be provided with the index of fire and egress door assemblies to help with accurate identification and inspection. Ideally, the owner's maintenance personnel should accompany third-party inspectors and be equipped to make minor adjustments during the operational tests. Adjusting door closers and latching devices during the walkthrough inspections increases the number of compliant openings recorded in the inspections. Inspectors need to conduct these inspections with the following key points in mind: presumption of correct applications, original building fire and life safety code requirements at the time of installation, practical application of inspection criteria. Presumption of correct applications. It needs to be stressed that the inspector should perform these inspections with the fundamental presumption that the correct door frame, and builder's hardware products were originally installed as a fire door assembly, and that the assembly provides the appropriate level of fire protection for the area of the building it serves. Inspectors should not be burdened with determining the correct level of fire protection ratings for each fire door assembly or locating and verifying fire barriers within the buildings. However, inspectors need to be capable of recognizing incorrect applications when they are discovered during the inspections. For instance, a three-quarter-hour fire door leaf installed in a stair tower fire door assembly most likely is an erroneous application. Stair towers require 1 hour or hour and a half, 60 or 90-minute fire protection rated door assemblies. Likewise, a stair tower door assembly with large vision panels might be indicative of an incorrect application and requires closer inspection to verify its compliance with Nfpa 80, original building fire and life safety code requirements. In addition to presuming that the correct doors, frames, and builder's hardware components were installed, inspectors need to be aware of the building fire and life safety codes that were applicable at the time of installation. The importance of this cannot be overstated. If In other words, inspectors should not apply the capabilities, limitations, and requirements for modern products to assemblies that were installed many years ago. For example, certain fire doors are listed for less bottom rod bolt application using modern products. However, very, very few, if any, of the older existing fire doors were designed or tested for this particular application. Therefore, these older fire door leaves cannot be permitted to be equipped with a less bottom rod bolt application without consulting the manufacturers, the testing laboratory, and the AHJ. Practical application of inspection criteria. Inspectors and AHJs need to apply the inspection criteria of NFPA 80 pragmatically. For example, NFPA 80 sections 484 and 6317 are both titled clearances. Each section lists specific maximum clearance dimensions permitted around the perimeter of the door leaf when it is closed and latched into the door frame. Many people are of the opinion that it is unrealistic to expect fire door assemblies to be installed within the specified clearance requirements of NFPA 80. In fact, when the door frames are properly installed, level, square, plumb, and true, the clearance dimensions between the perimeter of the doors and the door frames are usually within NFPA 80's requirements. Poor door frame installation techniques and practices are the most frequent causes of non-compliant clearances on fire door assemblies, as well as the causes of other deficiencies. Installation of the door frame is the single most important factor. Recently, new door frame and builder's hardware products have been developed to help mitigate the excessive clearance dimensions. AHJs need to determine the acceptable maximum clearance dimensions permitted within their jurisdictions before requiring corrective actions to be taken, which might include allowing new products to be used or requiring the door leaves to be replaced. After the inspections, upon completion of the visual inspections and operational testing of the fire door assemblies, inspectors might need to spend additional time verifying technical conditions they witnessed during the inspections before they were able to submit their reports to the owners. The language used in NFPA 80 frequently includes statements such as as specified in the individual manufacturer's published listings. Statements like these are designed to accommodate the varying capabilities and limitations of the products produced by the manufacturers. NFPA 80 recognizes that manufacturers are constantly developing new products and continuously subjecting them to fire testing. For example, the maximum size and configuration of vision lights installed in fire door leaves varies from manufacturer to manufacturer. In fact, the dimensions might vary within a particular manufacturer's product line depending on the internal construction of the door leaves. What might seem to be unacceptable at first might turn out to be acceptable after research has been conducted. Once all of the necessary research has been completed and the reports are finalized, the inspectors will present the reports to the owners and property managers. In turn, the owners and property managers need to decide how to proceed with the information documented in the inspection reports. Certain corrections might be as simple as adjusting hardware items, such as door closers, or removing kickdown door holders, or other corrective actions might be more complicated and require replacing major components or entire assemblies. All corrective actions made to fire door assemblies need to be fully documented, correlated to the inspection reports, and presented to the AHJ with the inspection reports. It is important to point out that the fact that fire door assemblies develop deficiencies is not a violation of the Building, Fire, or Life Safety Code. They are mechanical equipment that is subject to wear over time. However, failure to maintain fire door assemblies in proper operating condition is the action, or inaction as the case may be, that violates the fire, building, and life safety codes. Once deficiencies have been discovered, owners or property management personnel are on notice that they need to take immediate corrective action. That action might require ordering replacement parts that take weeks to fulfill, during which time the assembly might need to be temporarily fixed in the closed position, provided that the means of egress is not compromised. That is, as long as the AHJ is confident that corrective actions have been made or are in the process of being made, the building owner is in compliance with the intent of NFPA 80 as well as other applicable codes. Summary report. Inspectors should familiarize their findings as the date of the visual inspections and operational testing. The summary should include documentation supporting special applications and/or significant areas of concern observed during the inspections. Thorough summaries will cover 1. The general condition of the fire door assemblies, 2. The total number of inspected assemblies, 3. The number of assemblies with deficiencies, 4. The nature of the deficiencies, 4. The nature of the deficiencies, nuisance level, those requiring minor adjustments to operating hardware, critical level, those with significant deficiencies, missing door levers or broken glass, and then number 5, emphasis on the need to maintain fire door assemblies in proper working order. The summary reports should include date and time of the inspection and testing, name and physical address of building or facility, name and credentials of the inspector, inspector contact information, summary statements, signature of inspector, signature of building owner or property management. Detailed report. An inspection record for each fire door assembly needs to be included with the summary report to help the AHJ determine the overall condition of the fire and egress door assemblies within the building, structure, or space. This detailed information will guide the AHJ during the review of the inspection documentation. AHJs might spot check the fire and egress door assemblies to verify the accuracy of the inspection reports before issuing their approval. Detailed reports should include the following information for each assembly: door number and other unique identifier, type of fire door assembly, fire protection rating, remarks and/or comments, including documentation of special conditions affecting the assembly, list of deficiencies, recommended corrective actions. Maintenance reports. A maintenance report for each fire and egress door assembly should be available for the AHJ's review in order to confirm that the necessary corrective actions have been completed and are in the process of being completed. Maintenance reports should include the following information for each assembly: door number or other unique identifier, date of corrective action, descriptive of corrective action, date of operational test following a repair or replacement, name and company information when applicable of the persons performing the work. Repairing and/or replacing fire door assemblies. Before making repairs to fire door assemblies, owners and property managers need to confirm that the necessary work is permitted to be performed and will not further compromise the fire door assemblies. Section 5.5, Maintenance, gives direction for the repair and testing of fire door assemblies. Paragraph 551 states, repairs shall be made and defects that could interfere with operation shall be corrected without delay. Repairs to fire door assemblies also need to be performed in compliance with the requirements of Section 413. Appurtenances, I have to study that word every time I see it. Appurtenances, paragraph 513, replacement, and Section 514, field modifications. Record keeping. In most jurisdictions, the AHJs are not able to physically inspect each building and structure in their jurisdictions every year. However, an AHJ's inability to reach each building in a year is not sufficient reason for postponing safety inspections of fire and egress door assemblies and does not alleviate the owners or property managers from complying with the requirements of NFPA 80 or NFPA 101. During the AHJ's building inspections, owners and property managers need to be able to provide evidence that the fire and egress door assembly safety inspections have taken place since the AHJ's last visit. As previously mentioned, Section 5.2, Inspection and Testing, requires the periodic safety inspection records to be maintained for a minimum of 3 years. In cases in which the owner or property manager might seek to transition to a performance-based inspection program, the inspection records might need to be retained for 5 or more years in order to document the effectiveness of the door maintenance program. And now we move on to Section 9, Sample Forms, on page 53. Assuming that I get this all scanned, you'll be able to. I'll be able to look at the sample examples of samples. Inspection summary report, fire door assembly index. The summary report has the building name, the address, the summary, the date of the inspection, the inspector information, inspecting company's information, signatures of both the inspector and the building manager. The fire door assembly index is a summary listing, an itemized listing of the door number, the door type, its fire rating, its door location, and its remarks. There's a door type key. There's a door key to be used, which could be handy. Fire door assembly inspection survey form. Door number, whether or not it's compliant. Non-compliance codes, referring to the codes that it is running afoul of. This form is intended to be used to list detailed information codes specifically for each fire door assembly during the inspections and testing. That's where the fire door assembly inspector earns his gravy. Please use the following codes to identify problems on the door openings listed on the other side of the page. So there's a number of codes listed here that is a cheat sheet as far as I'm concerned that will permit you to look at and go through perhaps as a list of those items that are potentially out of compliance. Fire door inspection checklist on page 55. A variety of things that you go through to determine what's happening. A little bit too small to read. All right, section 10, other types of fire door assemblies. Typically, modern buildings have other types of fire door assemblies that are equally important to successfully protecting the lives and property of its occupants. These other types of fire door assemblies range from fire access doors, which are the least complicated, to large sliding or rolling fire doors that require specialized knowledge to accurately perform inspection, testing, and maintenance services. Contact professionals from the respective industries to locate qualified persons to perform safety inspections for these type of fire door assemblies. Section 11, new construction. The majority of this manual is dedicated to the necessity of maintaining fire and egress door assemblies in existing buildings. However, AHJs need to consider how they might address the installation and testing of fire door and egress assemblies in new construction and renovation projects once annual inspections become mandatory in their jurisdictions. At first glance, one might wonder why inspections of fire and egress door assemblies in new buildings are necessary. However, when you consider the overwhelming numbers of deficiencies found on fire swinging doors with builder's hardware that stem directly from incomplete or poor installation, you begin to understand the necessity for inspections at this early stage in the building's lifespan. Your office might decide to require full inspection and functional testing of fire and egress door assemblies on or before the date of substantial completion of new buildings to ensure that they are properly installed before the certificate of occupancy is issued. At this point in a construction project, the owner, architect, contractor, and material supplier have complete sets of door and hardware schedules and can easily document that their installation and function meet the requirements of NFPA 80 and NFPA 101. Corrective actions, when required, can be readily completed, ensuring that the fire and egress door assemblies in new buildings have been installed correctly and are functioning as intended. Another advantage of requiring formal safety inspections of fire and egress door assemblies before the issuance of the certificate of occupancy is that it determines the future inspection cycles for the building once it is occupied. Certificate of occupancy design officials and facility maintenance staff should collaborate in the design phase to locate the high-frequency usage and high-abuse door assemblies in the facilities. Together they can provide the most efficient assembly design both in function and ease of maintenance over the time of the buildings. To ensure the fire and egress doors are 100% compliant with NFPA 80 inspection requirements, design officials should incorporate into the construction documents the requirement of a fire door assembly inspection prior to issuing the certificate of occupancy. The initial fire door assembly inspection will provide the starting point for facility managers to build in the annual fire door and egress door inspections to ensure the safety of occupants, firefighters, and first responders in the event of fire or emergency. From the building owners and facility managers' perspective, ensuring that fire and egress door assemblies are compliant with all the codes and standards on the first day of occupancy reduces premature maintenance costs and provides a baseline for all future inspection cycles. Theoretically, routine inspection, testing, and maintenance of door assemblies that are correctly installed and that are functioning in accordance with code requirements shall be less costly over the lifespan of the building. Section 12, Summary, page 61. Fire door assemblies. Fire door assemblies are designed to withstand tremendous pressures and stresses under fire conditions. Metals rapidly expand, wood is consumed, but the door leaves must remain within the opening and form an impenetrable barriers for their rated duration, which might be up to 3 hours. Their fire protection provides occupants time to escape to the outside or to reach an area of refuge within the building where they can wait to be rescued. Many swinging fire door assemblies have complicated and sophisticated hardware products that provide convenience and security under normal conditions. These assemblies require an immense level of expertise to coordinate their functions with their fire protection properties. The information presented in this guide is intended to provide guidance to building owners and property managers who are responsible for maintaining the fire and egress door assemblies in their buildings and facilities. Each building or maintenance department should have a copy of NFPA 80 and NFPA 101 available for reference during inspections and when performing maintenance on fire and egress door assemblies. NFPA makes many of its publications available for reading online through its website at no charge. Users are required to establish an account on the website, which typically includes setting up their name and email address. To view the current edition of NFPA 80 or NFPA 101, simply go to the website and follow the on-screen instructions. We strongly urge you to proceed with these inspections cautiously. Seek out qualified individuals or training that will aid you and your staff in fulfilling your obligations under NFPA 80 and NFPA 101. Building owners and property managers are encouraged to contact their local AHJ's office and discuss the method in which these inspections will be enforced in their communities. We are at the glossary and we're going to read the glossary. I find that understanding the terms is the difference between understanding the subject matter and having no idea what they're talking about. The following list of terms is provided to establish a consistent level of understanding when reading this document. Italicized terms are excerpted from Chapter 3 of NFPA 80. Active leaf, the first operating door of a pair, which is usually the door in which a lock is installed. Approved, acceptable to the authority having jurisdiction. Architectural hardware consultant, AHC. An An industry professional certified by the Door and Hardware Institute with specialized knowledge of the specification and installation of builders' hardware products applied to the architectural openings industry. Architectural Openings Consultant, AOC, an industry professional certified by DHI who has attained AHC, DEC, and EHC professional certifications. He's the hat trick of all of them. I didn't know that. Astragal overlapping, a horizontal or vertical molding attached to one leaf of a pair of doors. Astragal split, a horizontal or vertical molding attached to both leaves of a pair of doors. Authority having jurisdiction, AHJ, an organization, office, or individual responsible for enforcing the requirements of a code or standard or for approving equipment, materials, and installation or a procedure. Automatic closing device, a device that causes the door or window to close when activated by a fusible link or detector. Automatic closing door, a door that is normally open but that closes when the automatic closing device is activated. Certified Door Consultant, CDC, an industry professional certified by the Door Hardware Institute with specialized knowledge of the specification, fabrication, and installation of architectural doors and frames. Closing device, a means of closing a door from the partially or fully open position. Coordinator, a device used on pairs of swinging doors that prevents the active leaf from closing before the inactive leaf closes. Door Hardware Institute. The Door and Hardware Institute is a professional organization dedicated to promoting life safety in public buildings through the development of codes and standards affecting the built environment. DHI provides training and is the certification body for AHC, CDC, EHC, and AOC professional certifications. Door closer, swinging, a labeled device that, where applied to a door and frame, causes an open door to close by mechanical force. The closing speed can be regulated by this device. Door protection plate, a protective material applied to the face of a door and generally made of approximately 0.05 inch, 1.2 millimeter thick brass, bronze, aluminum, or stainless steel, or 1/8 of an inch thick laminated plastic. Egress side, the side of an opening from which traffic exits. Electrified Hardware Consultant, an industry professional certified by DHI with specialized knowledge of architectural door openings operated by electrified architectural hardware and access control systems. Fail-safe device, a device that will provide its intended function upon loss of power. So fail-safe and fail-safe device are two different things. FDFR, fire door failure rate, measured average over a period of time. Fire door, the door component of a fire door assembly. Fire door assembly, any combination of a fire door, A-frame, hardware, any combination of a fire door, A-frame, hardware, and other accessories that together provide a specific degree of fire protection to the opening. Fire door frame, a component forming the perimeter of an opening in a fire door assembly that is supplied, welded, or knocked down and anchored to the surrounding structure. Fire door hardware. Door hardware furnished for swinging and sliding fire doors by the door manufacturer as a component part of the listed door assembly. Fire door, let's read that again. Fire door hardware. Door hardware furnished for swinging or sliding fire doors by the door manufacturer as a component of the listed door assembly. So I think if you're going to buy an entire assembly, fire door hardware is a part of that assembly. Fire exit hardware, labeled devices for swinging fire doors installed to facilitate safe egress of persons and generally consisting of a crossbar and various types of latch mechanisms that cannot hold the latch in a retracted locked position. I understand that there are also other differences in fire exit hardware when compared to panic exit hardware, and they have to do with the construction of the head case. I have seen specifically deadlocking tabs that exist on certain exit devices. that are fire exit devices and not panic exit devices. I'm not aware of other differences that might exist between the two, but I know that they are mechanically different devices. They are constructed differently. That I do know. And for sure the deadlocking tab I saw on one brand tells me is proof of that. Fire protection rating. For the purposes of this standard, NFPA 80, the designation indicating the duration of the fire test exposure to which a fire door assembly or fire window assembly was exposed and for which it successfully met all acceptance criteria as determined in accordance with NFPA 252, Standard Methods of Fire Tests of Door Assemblies, or NFPA 257, Standard on Fire Test for Window and Glass Block Assemblies, respectively. Fire resistant rating, the time in minutes or hours that materials or assemblies have withstood a fire exposure as established in accordance with the test procedures of ASTM E119. Flush bolts automatic. A mortised bolt installed near the top or bottom of the inactive leaf of a pair of doors that holds the automatic leaf in a closed position until the active leaf is opened. Flush bolts manual. A mortised bolt installed near the top or bottom of the inactive leaf of a pair of doors in which the bolts are manually extended or retracted into or out of the header or sill by means of a lever. Inactive leaf. One door of a pair of doors that ordinarily is latched closed. The second operating door of a pair. Labeled. Equipment or materials to which has been attached a label, symbol, or other identifying mark of an organization that is acceptable to the authority having jurisdiction, and concerned with product evaluation that maintains periodic inspection of production of labeled equipment or materials, and by whose labeling the manufacturer indicates compliance with appropriate standards or performance in a specified manner. Latching device, a spring-loaded latch bolt or a gravity-operated steel bar after release by physical action returns to the operating position and automatically engages the strike plate when it is returned to the closed position. Listed. Equipment, material, or services included in a list published by an organization that is acceptable to the authority having jurisdiction and concerned with evaluation of products or services that maintains periodic inspection of production of listed equipment or materials or periodic evaluation of services, and whose listing states that either the equipment, material, or service meets appropriate designated standards or has been tested and found suitable for the specified purpose. Minimum level of quality. An established level of performance for products, systems, installations, and construction that is the minimum acceptable under the building code or standard, not intended to exclude or prohibit products, systems, installations, or construction that provides increased levels of performance. Mullion, a fixed or removable vertical member set in a double door opening that allows both leaves to be active or set between a door and a side light or a separate framed glazed area. Strike mullion, hinge mullion would be terms where you're going to separate a door from more of the frame. NC, number of fire door assemblies inspected and tested in a period of time. NF, number of failures of fire door assemblies identified during inspections and testing over a period of time. Plant-on, a decorative trim applied to the surface of a door. Qualified person, a person who, by profession of a recognized degree, certificate, professional standing, or skill, and who, by knowledge, training, and experience, has demonstrated the ability to deal with the subject matter, the work, or the project. Self-closing doors, doors that, when opened and released, return to the closing position. Self-latching bolt, an automatic latching device that engages in a keeper to hold a door leaf in a closed position and that can be only released manually. That would be a self-latching flush bolt, where when the inactive door closes, it will latch automatically. The only way to get that open is to push the trigger button in the side. You have to manually open it. Shall includes a mandatory requirement. So if the word shall is used, that means must. Should indicates a recommendation, or that which is advised but not required. Should means, it's a good idea, but I can't force you to do it. Side light. An opening in a fire door frame. As an inspector, I can't force you to do anything, as said here. The AHJ, that would apply to. Side light. An opening in a fire door frame alongside the fire door opening that is filled with glazing material. Side panel frame. A door frame prepared for the installation of a fixed solid, metal, or wood panel alongside the door opening. Side light frame. A fire door frame prepared for the application of glazing material alongside the door opening. A side light frame doesn't have to be fire rated. Spring hinge. A closing device in the form of a hinge with a built-in spring used to hang and close the door. Standard. A document, the main text of which contains only mandatory provisions using the word shall to indicate requirements of which is in a form generally suitable for mandatory reference by another standard or code or for adoption into law. Non-mandatory provisions shall be located in an appendix or annex, footnote, or fine print note, and are not to be considered part of the requirements of the standard. Strike plate, a wear plate for projecting hardware, or a wear plate and keeper for a latch bolt. Transom, an opening in a fire door frame above the door opening that is filled with a solid panel or with glazing material. Transom light frame, a fire door frame prepared for the application of glazing material above and alongside the door opening. Transom panel frame, a door frame prepared for the application of solid metal and wood panels above and alongside the door opening. Wired glass, glazing material with embedded wire mesh. Section 14, the door security and safety foundation, DSSF, is dedicated to promoting secure and safe openings that enhance life safety through outreach efforts that include awareness and education within the building design, code authority, and facility management communities. Funding for the DSSF's programs and services is provided by donations from manufacturers, sales agencies, and distributors of architectural door and hardware-related products, as well as contributions from private individuals. For more information, please visit the Foundation's website, doorsecuritysafety.org. That concludes the reading of this book. So we're going to make an attempt to scan everything that was just read so that it can be viewed along with hearing it verbally. And that is the purpose of the fire door assembly inspection reading of the manual. Thank you very much. Rich Howard, owner of Architectural Builder Supply.